Joe Rogan Podcast. Check it out.
The Joe Rogan Experience.
Train by day, Joe Rogan Podcast by night, all day.
All right, we're up. What's happening, Rhonda?
Hey.
Very good to see you.
Good to see you. It's been a year.
It has been. It's been quite a while.
Yeah.
And you were just telling me that you're 13 days into keto.
I am.
How you feeling?
Well, let's start off with, why did I even want to do keto? Why now? I mean,
Right.
This has been how many years that it's been trendy. It's been like lots of benefits. And it's like, why did I start trying it out now? Well, I've noticed that when I am in a fasted state, so when I'm in ketosis, when I'm, burning fatty acids and making keto bodies and using them as energy, I'm like on top of my mental game. So I've been doing, like when I have any sort of like podcast interviews I'm doing or whatever, I'm always trying to do them fast. Like I'm fasted right now. And so I thought to myself, like, is this something that could be mimicked by a ketogenic diet? Like, it's very noticeable for me where I can stay focused. I have more endurance. So, like, I don't, crap out, like
More
couple hours.
mental endurance.
Mental endurance,
Yeah.
sorry, yeah. More mental endurance. So, so I decided to try it out. And I recently had a neuroscientist on the podcast, Dr. Mark Matston. Have you heard of him?
No.
He's like legendary. I mean, he's probably one of the most cited neuroscientists, but he's most well known for his intermittent fasting studies, like the 5-2 intermittent fasting stuff came out of his lab. He's also sort of the father of hormesis and like why, humans sort of adapted to be in a stressful environment and how, all these stress response pathways that happen, as a response to that are beneficial. But anyways, so he was talking about like when you're in a fasted state, when you haven't eaten, how your nervous system has sort of evolved to become like more focused, more alert. And that's adaptive because if you can't find food, you have to be like alert in order to like eat or else you'll die. So, so he's talking about like one of the main things that happens is this metabolic switch, is what he calls. But so you do switch from burning glucose, as a source of energy to basically, fatty acids are immobilized from your adipose tissue and go to your liver and you start to like oxidize them and use them from energy. And then you make something called ketone bodies as a byproduct, beta hydroxybutyrate, acetoacetate. And most people think about these, well, this is an alternative source of energy. It crosses the blood-brain barrier. It, is easily used by, neurons and other cells as well. But it's actually an energetically favorable source of energy. So it actually requires energy to use glucose as energy, to make energy from glucose, requires energy. But beta hydroxybutyrate, that doesn't happen. Like it goes into the mitochondria and it's used without that energy requirement. So you can imagine.
Explain how that works? Like that you use energy to use glucose?
Yeah. So glucose gets broken down into something called pyruvate. And pyruvate, so it takes energy to do that. And then pyruvate has to be transported into the mitochondria through a like active transport mechanism. And that requires energy to do that. Once it gets into the pyruvate gets into the mitochondria, it's then used through what's called the TCA cycle to make energy. So beta hydroxybutyrate gets converted into acetyl-CoA, and beta hydroxybutyrate can just go in without like this active transport mechanism. So you're not requiring that energy to transport it in. Does that make sense? So you're making energy, but you're not using as much energy to make that energy. So that's kind of like what most people are thinking about is this sort of metabolic switch that happens. And you can imagine most people never do that. Like I typically, I do a lot of time restricted eating where I'll eat my food anywhere between 8 to 10 hours. And then I'm fasting anywhere between like 14 to 16 hours a day. And in order to actually go into this metabolic switch, you have to deplete all of your glycogen levels in your liver and muscle. And that usually takes anywhere between 13 to 36 hours, depending on the person's carbohydrate intake, on their physical activity. And so, most people never get that metabolic switch. Most people are just constantly burning using glucose. And then when you're doing that, any fat that you're taking in gets stored as triglycerides in adipose tissue. So they're always in this like fat storage state instead of a fat burning state, right? And so, because most people are eating 3 meals a day and plus snacks, you never get there. So, with the anywhere between 14 to 16 hours, is what I typically was doing. I'd noticed that like I was really mentally sharp, and so as I extended that out a little bit, it was like really clear to me that like not eating was like good for my brain in terms of like I felt smarter. I felt like I could focus more. Like, it was noticeable, like a nootropic effect, right? And so one of the other things that's probably less well known about beta hydroxybutyrate, which is one of the major circulating ketones you do make when you're in ketosis, is that it is actually a signaling molecule. And this was shown by Dr. Eric Verdin. He runs the Buck Institute for Aging in Novato, California. He showed back when he was at UCSF that beta hydroxybutyrate activates many different genes, one of them including brain-derived neurotrophic factor, BDNF, which I know we've talked about before in the podcast. But that's something that is critical for, forming new synapses and for learning and memory. I mean, there's all sorts of things that it does. But beta hydroxybutyrate is activating that. Like, it's not just something that's being used as energy. Like, it's changing gene expression. So that got me really interested. It's like, wow, this is something that like could be possibly also activating BDNF. Maybe that's partly why. I mean, it's a hypothesis, but it seems like something that people could test, and it seems kind of, it makes sense, right? Mm-hmm. And so that was something that I was like, wow, what if I could do? So I asked Dr. Mattson, I was like, there's lots of, differences between being in a fasted induced ketosis and a ketogenic diet. But there's also a lot of similarities. And the similarities are, one, you're making lots of beta hydroxybutyrate. If you do the ketogenic diet right, we can talk about that. But, and so I was like, wow, well maybe, and then the other thing that overlaps between the two is that you produce a lot of GABA. GABA is the neurotransmitter that's typically more of an inhibitory type of neurotransmitter. I'm sure Dr. Dom D'Agostino has talked about this. I think I even remember him talking about it before, that GABA is increased on both, ketogenic diet and when you're in like a fasting-induced ketosis. And GABA is, it kind of has an anxiolytic effect, so like helps calm you a little bit, but also seems to affect, and this is what, some researchers think the reason why a ketogenic diet is so beneficial for like drug-resistant epilepsy is through GABA, because it quiets down the neurons that have been excited through glutamate. So like right now, we're like having an intellectual discussion, and we're like intellectually engaged, and so glutamate's being fired, right? And it can do a lot of damage. Like glutamate, having this like constant electrical activity, like very stimulating. You need something, like if you didn't have GABA, you'd fry your brain, like without it, like with too much glutamate. So it can cause something called excitotoxicity. And so GABA kind of counters that. And so anyways, some of the things that I'm noticing now that I've been on day 12 or 13, for one, it's been incredibly hard. So I've been measuring my beta hydroxybutyrate levels daily, sometimes more than, once a day, of course. And to be in like mild ketosis, like legitimately mild ketosis, like I think, you want to be somewhere between like 0.9 and like 1.2. I mean, that's like mild to moderate. And I can't tell you how difficult it's been for me to first get to that point. It took several days, and it's like, I think people, probably like 90 to 98% of people that think they're doing a ketogenic diet, they're not. Because
really?
I think so, yes, because it's not just enough to do carb restriction, and like you need a lot of fat. Like you need, especially in the beginning, like if your body, like me, so I've always, for the most part, my diet has been what you would call paleo-ish. I would, I would have my protein and vegetables, and I generally speaking avoid like the refined stuff, refined carbohydrates, refined sugars, right? But I do eat vegetables, which are carbohydrates, and I also eat some fruits. And so my body's used to like metabolizing the glucose and doing that whole pathway, we were talking about like from carbohydrates. And the fat that I'm getting mostly probably is being stored, honestly, as triglycerides. But it takes a while for your body to switch to that. And I was surprised how long, because I thought, well, I don't need all that refined stuff, so it should be easy. It's just a little, like, it has been a huge challenge. And you read about all these foods that are like, okay, vegetables that are keto friendly, you know, like cauliflower or Brussels sprouts or a little bit of spinach, or like I will eat like just a little bit of sauteed spinach and it'll take me, I will be in like 1.2 millimolar and it'll take me down to like 0.7. You know, so it'll kick me out, just a little bit of something. And if I'm not eating enough fat, like I can't even like get, so I finally was able to, now I'm like doing like butter in my coffee and I'm just like trying to get like olive oil on everything and MCT oil in my coffee and just like lots and lots of fat. When I started doing that, I was able to get up to like 2.2 millimolar, which is like good ketosis. And then like I came here, traveling is really hard. I ordered some, like I had a steak and then it was some kind of cauliflower mash with like cheese and bacon and that kicked me down to like 0.4. Like I was so upset. Check my
So it's just the cauliflower?
Just
or is
the
it...
carbohydrate and the lack of not having as much oil, I think. Like, so like I have the protein, so you can convert. So the thing, like there are what's called glucogenic amino acids and those can be converted into glucose. Your body has a way. You need glucose. Like you can't, like your red blood cells don't have mitochondria. The only source of energy they can use is from glucose. Your brain, you know, your astrocytes and their supporting cells in your brain are mostly glycolytic. They mostly use glucose. You need glucose. So your body has mechanisms to make it. You know, you can make it from these gluconeogenic amino acids, which are in protein, or you can make it from glycerol, which is like the background of a triglyceride. But, you know, I think once you become adapted, and this is something that I know like Dr. D'Agostino has talked about a lot, where he's got more of like a modified ketogenic diet. But he's been in it for like years. You know, he's like done a ketogenic diet for like years. And like he can eat something that it's like a lot more, like you can have the protein and the like keto friendly carbohydrates, like the leafy greens, you know, that are not like super carb.
And it won't kick him out.
Yeah, he seems, because he's like adapted. But you know, you read all these recipes, like I'm going online, I'm trying to do keto recipes and all this, and it's like none of them work. None of them work. All the stuff that you like find in the store that says keto on it, totally not. Totally not. Like,
really?
Oh yeah, because they have too much carbohydrates and not enough fat. It's like, and then they do this thing with this net carb, you know, fiber. I'm telling you, like if people were to measure their blood levels of beta hydroxybutyrate, they would know. Like this, it's
and
not.
What is the best way to do that? Is the best way to do it through ketone strips? Is the best way to do it through like a breathalyzer type deal? I personally
always think blood is the best. I'm not an expert. I mean, I haven't actually done a deep dive on all the different methods. Personally, I like if you're measuring glucose, for example, like blood is more accurate than like interstitial fluid area. Like, so I like to use this, you know, precision extra that you can get, and you can get these ketone strips, and they're actually a lot cheaper than they were like a few years ago. They used to be really expensive, and I do that, and I think that's the way I prefer. I mean, maybe there's some accuracy in some of the other ones, but I don't really know, honestly.
Is there any benefit to using exogenous ketones?
So, I'll tell you what I think the benefit is. It's probably not something you're going to expect. So I've tried exogenous ketones many times, beta hydroxybutyrate ester. The salts like I'm sure like Dr. D'Agostino has talked about that as well. Like they don't work as well, like in terms of like actually raising you up to a millimolar level in terms of.
So what is the difference in the actual name of the supplements? Like the salts
will be like a salty powder thing that you like add, and the ketone ester will be a liquid.
Okay.
It'll be a liquid. And
so the liquid is more effective than the salts. Salts are not very effective at all.
Not very much at all. And plus they like can give you GI distress and stuff. And a lot of them have a lot of either sodium or calcium, depending on what it's complex to. But so one of the things that's interesting about the beta hydroxybutyrate exogenous ketone esters, and I've tried a few different brands, they all work pretty well. They'll raise you up. Like if you, for example, if you drink like the whole serving, most of them are like 30 mils. They can take you from 0 to like 3.3 millimolar, like that. I mean, like ketosis that I haven't been able to achieve yet from 12 or 13 days of a ketogenic diet. And so you can experience some of the like effects, but it also has the effect of lowering your blood glucose at the same time. And it's like, this is something that researchers are actually looking into, like, oh, this could potentially help people that can't regulate their blood sugar levels, you know.
And this is only through exogenous ketones, the esters?
The exogenous ketone esters, yes. I have
so
not.
It lowers your blood glucose
dramatically.
Wow.
But the problem with that is they're very short-lived. They're very transient. So, like, every time I've done it, like, they wear off, like, 2 hours max. 2 hours max. The problem is your blood glucose is also dramatically lower. And if you don't eat, if you don't, like, replenish that, like, you can crash hard. Like, you can crash hard because you have no beta-hydroxybutyrate around as the energy source. Now, whereas you're in ketosis, actual ketosis, your blood sugar levels are lower, but you're making beta-hydroxybutyrate, right?
Would there be a benefit to do that? Like, say, if you were going to do something that was like mentally taxing, if you're going to take a test or something like that, would there be a benefit in taking exogenous ketones?
So I used to kind of use them that way, but again, if you don't, it's short-lived. And
would you take it with some sort of glucose?
I used to take it with carbohydrates, yeah,
like fruits or
like
something,
like oatmeal or fruit, exactly. But even that, like, you know, your blood glucose will peak and then 2 hours later it's going to go back down. So you need to like keep that source going. So I noticed that like several times. It was like, oh, this is good for really the peak of it was like an hour.
And is there, when you take these ketone esters, is there a number of them? Like, is there an amount you can take in a day? The amount of times you can take it in a day? Can you only do it once? Like
people, I mean, some of these companies that make them claim you can do it more than once a day. I know people that do it. Personally, I think the benefit of the ketone ester is, and I'll tell you what I've used it for. I tried the mental stuff, but so getting someone who you think will benefit from ketosis, from a ketogenic diet, getting them to do it, like this diet is hard. It is hard. It's hard. I can't like emphasize it, like actually doing it, like. I'm telling you, I think people think they're doing it and they're not. What they're doing is just a low carb diet. It's different. Anyways, so like convincing someone to do it is difficult, like very difficult. And so if you give them the exogenous ketone ester, they can experience, oh, I would feel this way. I would feel this way more often if I could, you know, first of all, initially do the ketogenic diet. So I did this with my mom. So my mom has two types of motor dysfunction tremors. She has essential tremor, which is the kind of tremor where, like, you know, you kind of just shake like when you're doing something or grabbing like a, you know, some spoon or whatever. And then she has orthostatic tremor, which is like tremors like where if she stands still, like her legs shake really fast. So she can walk fine, but if she's standing, it's really hard. So she has to like not stand. She has to sit or walk or move. And with all the research on the effects of ketogenic diets on epilepsy. And then there's also some data, and Dr. Mattson talked about this with me because he actually worked with the late Richard Veach on this, who was like the guy who invented the ketone ester. They're showing that it helps with like Parkinson's disease in animal models, Alzheimer's disease, like, and that's, you know, something that's a little different than motor dysfunction. But so I wanted to give her this ketone ester to say, look, the ketogenic diet may be beneficial for you. Let's see. And it absolutely helped mostly with her essential tremor. But she noticed a little bit of an effect with orthostatic. Now, of course, there's always the placebo. You can't placebo this. It tastes like shit. Like, you can't. Like, I mean, maybe you could, but it's hard to come up with the placebo. I mean, people drinking this are like, okay, I'm getting a ketone ester.
I've tasted it.
Yeah.
It's rough.
Yeah. So, you know, it's kind of like
gasoline.
There's always that, right? Yeah. So, so she's done this enough times. It also helped with her migraines. Like, so, and there's like literature, a body of literature out there where it helps. Ketogenic diet's been shown to help with migraines, both prevention and treatment. And then there's like one study showing ketone ester can help with migraines as well. I mean, they're like not like the best done, you know. I mean, there's no placebo and all that, so you have to like take it with a grain of salt. But she's now been on the ketogenic diet with me, and she's having the darndest time getting into ketosis too. Like, and she's not doing the butter and the coffee and like all the like fat. Like, I'm just really trying to get as much fat as I can.
How is she doing it?
Well, she's been eating the same meals. So like, and she's a person that was like refined carbs, woohoo! You know, like, I mean, she's like someone that I've had to work hard on to get her to stop drinking sugar-sweetened beverages. You know, like she thinks it fixes her migraine and...
Coca-Cola?
Yeah.
She would say it fixes her migraines?
Yeah, it does. Like,
does it?
According to her, I mean...
Is there any reason why it would
maybe
do that?
some caffeine. The caffeine's been shown to help. Also, potentially, like if she's having, like, if glucose is having a hard time getting into her brain and being used by her neurons, like maybe that, huge sugar rush from the Coke is going to help. All the more reason, like there's been evidence, both animal and some early clinical evidence, that basically you can take someone with like early dementia and the signs, one of the earliest signs actually of both Alzheimer's disease and I'm not so sure if it's also dementia, but definitely Alzheimer's disease is impaired glucose, like brain use of glucose. Like people, like their neurons and stuff are not using glucose well. And so like naturally, of course, beta hydroxybutyrate would be an alternative to that, you know? So anyways, what was I getting at? Oh, yeah, basically there could be some effect with the glucose rush for her headache thing. But again, the exogenous ketones worked. They did. And so like I've given it to her and she's been wanting to do this is we've known this for like over a year. And she's been wanting to do the ketogenic diet, and I think it just finally took me doing it to like get her to start it. Cause like,
does she live in the same neighborhood as you?
No, she's close. I mean, she's in the same city.
Okay.
And she comes and helps out with like my son. So she's at my house like
so you
3 or
can
4 days a
help
week.
show her what foods to eat.
Yes.
What are you trying to get her to eat, like specifically?
Well, right now I've been so busy, and so I've been like doing the lowest hanging fruit in terms of what's like the least amount of work.
Bacon.
I've got a bunch of bacon in my purse right now because I got to catch a flight after this, and I'm fasted. I'm like, I got to eat something before I get on the plane. Anyways.
What about beef tallow? Do you ever scoop out beef tallow?
Not yet. But like, so what I've been doing just these past 12 or 13 days is what I thought was going to like really get me in ketosis and be a ketogenic diet, which was like protein, avocado, olive oil drizzled all over it, like some of the high-fat, low-carb nuts like pecans and macadamia nuts. And then I thought, oh, well, you know me, like micronutrients, I need the magnesium. So avocados are great. They're giving me a lot of stuff like potassium, but the magnesium, which I'm now supplementing with, is something that's been hard to get without my leafy greens. And my leafy greens have been like kicking me out of ketosis. So I have to...
Even if you like drench them in butter and...
I drenched it in butter and olive oil, and I cooked down the spinach when you cook it down, like, so it's a lot more carb actually when it's cooked. And
really?
I should have thought, yeah, because haven't you ever sauteed spinach? I mean, you're like,
right, but I never thought it would be more carb
because you're eating more of it. You're eating more. You don't like
right.
if you're to eat a spinach salad. You would stop. You're like, oh, this is a big old bowl, like too much.
Right.
But you eat that sauteed spinach, and it's like it was like a little portion.
It is
like,
kind of crazy.
How much spinach was in there? I don't know.
Right.
Yeah. So of course, everything that I was like, yes, I can do my leafy greens on. I think I will be able to eventually, but not initially. Not initially, for sure. And
so you have to supplement. Magnesium.
I am.
Anything else? Selenium? Is there any other things that you're supplementing with?
Use selenium and meat and stuff. I mean, I get it. My multivitamin has all that stuff anyways, but I usually don't have to take extra magnesium because I usually get so much from eating dark leafy greens. And so that's like the main one that I've added.
And you're eating meat pretty much every day?
Yeah, every day. So
what kind of meat? Like ribeyes, like something
ribeyes.
fatty?
I had ribeye. Yeah, last night I had a ribeye. The stupid cauliflower hash with it was like a keto place. I ordered it from my Postmates to my hotel, and
they have a keto place.
It's called Keto Kitchen.
Oh, but it's not
found
keto.
It on the cauliflower. Kicked me down from 2.1 to like 0.4. Like I was so upset, and then I did bounce back somewhat. I was 1 millimolar this morning, which was good, but still, I was pissed. Yeah. So the cauliflower hash.
First world problems.
Hard. Yeah. It's hard to get up to 2.2.
So is it a matter of like doing it for long periods of time where your body becomes fat adapted and understands it and gets accustomed to it? Is that what it is?
Yeah, I think so.
Is there an actual like a mechanism that's causing this process to be like more robust over time?
That's a great question that I don't know. I've been wanting to know the answer to, like, what's the actual mechanism? And, all I can come up with is like, it is, you're getting your liver to like, it's always easy. It's just easier to like use that glucose. You use it, so like getting the liver to like oxidize the fatty acids and then make the ketones on top of that. Great question. Maybe Dom D'Agostino knows. Maybe I'll figure it out. I don't know. Okay. But there's something like it's real. Like it's real, and I think maybe there's probably some individual variation there too. I mean, there's lots of genes regulating these things.
When you're getting your mother to take the ketone esters, and there is that issue that you were talking about,
glucose drop.
So how do you mitigate that with your mom?
Well, she usually will like get some orange juice and like eat some oatmeal with fruit in it, and she's like increasing her carb intake basically. So, but still, for someone like me, it's like even like a little bit of carbs that I eat with like the vegetables and stuff, it's just I will crash. Like I will crash hard. So I prefer. So I started doing this whole like, okay, fasting in the morning. Like I've noticed like I'm more mentally on my game. And then it was like, okay, well maybe I could just try the ketogenic diet. Like what have I been so, getting the like micronutrient intake has been very important to me. And then of course like I was pregnant and then I breastfed. I did an extended breastfeeding, and all this time I didn't want to do any restrictive diets really, and then the pandemic hit and it was just like all this, excuses, but I finally got the motivation once it was like very noticeable mental.
Now I know you exercise a lot. Do you notice a difference in your energy levels with keto? Because I found when I tried it that at least the initial part of it was very difficult to work out hard.
I did not work out hard. I haven't actually worked out really hard for 12 days. Yeah.
Because you're giving your body a chance to adapt?
Mostly because I've been so damn busy, but I just haven't been. I actually probably should have been working out more, because you can actually kick yourself into ketosis by doing that, because you deplete your glycogen stores in your muscle and your liver.
Is there any specific type of workout that's better for that?
Aerobic, definitely. But on the flip side of that, if you're doing strength training, you remember we talked about the glucogenic amino acids? Mm-hmm. So gluconeogenesis refers to the process of your body making glucose without having to have a carbohydrate source. So your body can make it from these specific certain amino acids. There's quite a few of them. And also from the glycerol backbone of, triglycerides. You have 3 fatty acids on a glycerol backbone. When you sort of break that up, that backbone can also do that. So strength training can cause you to take amino acids up into muscle. And some of those glucogenic amino acids are like some of the branch chain amino acids that you're taking up into muscle. So you're basically, if you're strength training, I don't know if this has been shown. It's like, a theoretical speculation, but like in theory, you should be taking up some of those amino acids and not converting as much, because that's another thing. Too much protein, if you just, without the fat, like could potentially kick you out. And
right.
I'm probably also experiencing that. 'Cause I'm like, I gotta eat. I'm like, all I'm eating is avocados. I have like avocados in my bag. I traveled with them. I'm like what else can you do besides all the oil in like the coffee?
What do they do when they check you at the airport and they find all this food in your bag?
They didn't do anything.
Like, what's wrong with this lady? She's got bacon and avocados in her bag.
Well, it's a good thing, because I mean, it's really like,
yeah, everything's carbs at the airport.
It's all carbs, and I didn't eat anything on the flight. It was like,
that's the difficult aspect of it is the gluconeogenesis, right? So if you just eat meat, your body's going to eventually convert that to glucose, and that'll kick you out.
Yeah.
So you have to have meat with lots of fat.
Exactly. And that's the thing that I'm learning is that, I mean, at least initially, like I said, there are people out there that have been doing this for a long time, and I'm sure they're much more of an expert. They can tell you exactly what you got to eat and when you can switch over to more of that. But like, I'm learning about this, and I'm going, holy shit, like I thought I could just eat some meat and restrict my carbs and like I'd be in ketosis. And
Dom DeAugustino, he would travel with oysters and olive oil.
so I have sardines in olive oil, and they're like my favorite because they are really high in omega-3. There's like almost 1,000, there's like 800 or something milligrams of EPA and almost like 500 or something like of DHA. There's like literally like a ton of omega-3 in my sardines, and they're in olive oil. The olive oil tastes a little fishy, but I also have a little chili in it. So it's like a spicy. So I've got like four or five of those I brought with me.
Did I tell you that I used to eat those every day? And then I got my blood work done. I had a level of arsenic that was a little disturbing. And the doctor started asking me questions like, "What's your diet like?" We go over that. He goes, "Is there any? Do you eat any canned fish?" And I said, "Yeah, I eat sardines like every day." He goes, "That's it." He goes, "Cut that out. Let's try it again in a couple of months."
And
so it was gone.
It was specifically it was arsenic.
Mm-hmm. Yeah, arsenic.
Really?
Yeah.
No. So that's interesting because
they're dirty little fish. They're dirty little fish at the bottom of the sea.
I'm gonna have to do I've done an arsenic test before. And
how long ago?
It was like maybe 2.5 years ago. 2.5 years ago.
But you weren't eating, like you're eating these every day now?
I mean, I was not eating these every day when I did this test.
But
no,
you are now.
I am now.
Yeah, you should.
So I
got to
do it.
Yeah, 'cause they contain a lot of heavy metals apparently.
Oh my gosh, that's crazy.
Pollution.
Oh no.
Oh no. I mean, this is just my experience. Maybe.
What am I gonna eat, Joe?
Well, maybe there's cans you can get where they get it from better sources. I don't.
Yeah.
This was quite a few years ago. I don't remember what source I was getting it from.
Because they're so tiny little fish. You'd think that
they're dirty little buggers.
You'd think they'd have lower levels of that stuff.
They're
like
at the bottom. They're at the bottom.
Yeah, but they have lower mercury, much lower than like a bigger fish. So I guess it's not the same with our.
I don't
arsenic.
know. I mean, it could have just been the source I was getting from. Maybe other sources have no arsenic. I don't. I mean, they're a really well-traveled fish, right? They're available in a lot of different parts of the world, I believe.
Well, I'm glad I wasn't eating them every day while I was breastfeeding either, because I didn't want to transfer that to my breast milk.
But there are warnings where people say you shouldn't, particularly like freshwater fish. I was reading about this guy. No, I was listening to a podcast about this guy who got mercury poisoning, and he was a freshwater angler, and he would compete in a lot of fishing tournaments, and he ate fish like pretty much every day, like freshwater fish, and he developed mercury poisoning, like pretty severe mercury poisoning.
Yeah, I mean, you definitely can get mercury poisoning from eating certain fish.
Dangers of eating anchovies. Oh, I was eating sardines, but
right,
different thing. Yep. But a couple friends.
They got some parasite.
That's a different thing.
That's a whole other.
Never mind.
Associated with eating sushi, the ingestion of anchovies infected with parasites. Oh, great! Fun.
Sushi is like. Raw fish is also higher in mercury. When you cook the mercury, the levels go down. Yeah,
I've heard that raw fish is very high in it.
Higher in it.
People that eat a lot of sushi, they can get mercury issues, right?
Yeah.
And is it saltwater versus freshwater? Is there?
I didn't know about that. What I know about is like the size of the fish. Like the worst thing you can do is like eat swordfish. But like as you go down, like there's certain fish like salmon. Sardines are really low in mercury. Salmon, sardines, some anchovies as well, but other issues.
The bigger fish.
Yeah, because they eat like smaller fish and it accumulates. Yeah, so it's like accumulating in their fat. So those I always try to eat fish that are lower. They're high in the omega-3 index. Like wild Alaskan salmon is my favorite. It's high. It's a fatty fish. It's also great for the ketogenic diet because it's a fatty fish. It's high in the omega-3 levels and lower in like, things like mercury and stuff like that. And so, another way obviously to get the omega-3s, which I'm like super big on, and there's actually a couple of really cool studies you might be interested in that just came out on longevity, but is to take like a fish oil supplement. Of course, you can't, it's not sustainable. Like if the entire world were taking fish oil, like, so there's we got to figure out other ways, to like get these omega-3s.
That argument is always odd to me because, the entire world, it's not sustainable. But is it available to you right now? Yes. So, like, what are you doing? Like, I don't understand those arguments because, like, you can't convince the whole world to do certain things. Now, if the whole world started taking omega supplements and then it became a real issue with, supply and demand, but they're not. So, like, I get so confused when people want everything to be sustainable to the whole world. Like, when I've told people, like, I think that eating wild game is healthier, they'll go, yeah, but that's not sustainable for the whole world. Like, the whole world's not doing a lot of things. The whole world's not exercising. The whole world, like, listen, I'm just talking about what's available for you currently as a human being listening to this. Like, is it available for 8 billion people? No, it is not. But guess what? You're not going to motivate 8 billion people to do anything anyway.
Right. Oh,
So
it's funny you mentioned that.
Conversation is bananas to me because people always want to use it as an excuse to not do something healthy.
True. Did you know about, you mentioned the wild game, and like if we could go back to omega-3, I'd love to, but like I've looked at some studies. So when the pandemic hit, I like bought a bunch of like, wild elk and like claim to be wild,
It's definitely not.
Okay.
It's all from New Zealand, most of it.
Is it?
Yeah.
Okay. Well, I was buying that, and then I was buying like pasture raised, this and that, of course. And so we looked into like the differences of like, looking at like vitamin and mineral profiles and, the omega-3 fatty acid profiles and the fat and the macronutrient protein and all that. And like elk, for example, wild elk, like wild game, like you're getting, it's interesting. It does have like higher concentrations of some like minerals and micronutrients like zinc. Like, so you're getting like a much higher level of some of those things. It has higher levels of omega-3, like ALA and some of the omega-3 fatty acids compared to conventional. But anyways, yeah, I mean, in a way, if you define healthier as more micronutrient packed, it's
healthier. Yeah. It's also, it just looks healthier. If you look at it, like the other day I cooked a piece of beef and then I cooked a bunch of elk, and my family was, we're eating both. And we're looking at the elk versus the beef. The elk, it's so dark. It's so dark and rich, and it just, you can't eat as much. Like, you get full quicker. Like, your body gets satisfied by it quicker. But it's also, there's just whatever is causing it to be so dark. It's quite evident when you look at it that one of them is more attractive to you. Right.
I don't know if it's as simple as like the stuff that you buy at the supermarkets just oxidizing out in the air.
It's just the diet, because if you get grass-fed meat, it's a darker meat. Like, grass-fed beef is quite a bit darker. Grass-fed, grass-finished beef is much darker and has much less fat, and it looks much more like, and it tastes much more like game. Some people do not like the taste of grass-fed meat because it actually tastes like meat. When you're getting grain-fed cows, which is what most people love, you get that juicy, like really fatty meat. That's a dying animal. That's an animal that, if you just let it eat like that, it would just tip over and have a fucking heart attack.
Well, they've compared it. You're right. It is like the conventional is fattier as well. And before 2017, like that's, for a long time, I was like, the main reason I was avoiding conventional meat was because, these, I don't know what you call them, these farmers, the ones that are growing, like having the cows all packed in and they're,
factory
farm.
Yeah.
They were feeding them antibiotics, not because they had an infection, but because it made them bigger, right? Like,
that's why they fed them antibiotics?
Oh, yeah. So the FDA in 2017, you didn't know about this? So
I thought it was as a reaction to the issues that they were having by eating corn.
Well, I'm sure some factory farmers were doing it for that, but by and large, like there was a huge effect if you gave like a cattle or one of these animals antibiotics. It like made them grow bigger.
I wonder why.
I don't know. I honestly don't know. But it was like causing antibiotic resistance, like was going through the roof because it was like leaking into like all the water supplies, and not to mention...
That is so scary to me. Antibiotic resistance is so scary to me because I know several friends that have had MRSA infections, and they are absolutely terrifying. Because when you do get MRSA, like friends that have had staph infections and it got really bad, the doctors tell you, like, this is touch and go. Like, you have to be in the hospital on an IV drip of antibiotics for weeks. I had a friend who was in there for weeks, and he is young, healthy black belt in jiu-jitsu. He got a MRSA infection on his knee. They had to cut his knee open like a fish, like pull it to the side to drain it and like to constantly clean it. It was horrific. He almost died, and he was in his 20s. And he really healthy, really active, elite athlete.
Yeah, MRSA will take anyone down. I agree. That's scary.
And that's a direct result of antibiotics. The use of antibiotics has created this strain of really potent staph.
And believe it or not, a lot of it was coming from this agricultural use of it.
Really?
And so the FDA shut that down. They said in 2017, because of antibiotic resistance, if you're a factory farmer, whatever, you can't give your animal antibiotics unless it's prescribed by a veterinarian and they have an infection that you're trying. Now, you might find people still doing it. You can find veterinarians that'll give you anything, right? So, but they put the kibosh on that.
So these animals, they were feeding them just to get them bigger, and it was causing strains of antibiotic resistant the staph or whatever it is? Bacteria?
Yeah. Yep.
Wow.
Yeah. So that's one good thing that since 2017, which isn't that long ago.
How was that making the jump to people?
It was getting into the water supplies. I think it was just causing these strains to become resistant, and then the strains come to people. So imagine the amount of antibiotics to just nationwide in the United States alone, how many they're using on all these, and it was chickens. They were doing it for all these animals. It was making them
big.
And they're
only doing it to make them big.
Yeah,
that is wild.
Yeah.
And do we know why it makes them big?
I don't remember. I think I looked into this years ago, and this was when I was into that whole thing. I think there is a mechanism that's known, but I don't remember exactly what it is. It probably has to do with microbiome composition. Certain bacteria, certain bacteria probably go away, and the other ones are making you get the energy, because you can harvest energy better from certain bacteria in your gut. So it probably has to do something with that, but I just don't remember the exact mechanism. It's crazy though, right?
It's the scariest to me, because I've had really healthy friends get taken down by it, and you find out that the doctor says, "Hey, we don't know exactly if you're going to live." Yeah,
that's crazy. So I had a great uncle that just died of a staph infection. He went in for, some kind of type 2 diabetes complication, kidney or something, and got a staph infection while he was in there, and that's what ultimately took him down. It's a scary thing.
It is.
There was a Nature paper published, literally right around, it was a year and a half ago, and it was titled something like some medieval treatment to, antibiotic resistance or something, and it was all these components used in chimichurri sauce, where it's garlic and basil and parsley, and a lot of these plants do have antimicrobial activity.
Well, you talked about it, that the issue that you had with staph that you actually fixed with using garlic on the actual infection.
This is a total anecdote, and I had never tested the actual abscess to know if it was actually MRSA. But my anecdote goes as this. I came down with an abscess, and the first time I had it...
Where was it?
The first one was on my butt. And that had to be they removed it, and there was a couple of inch hole. It was necrotic. It was bad. And so that healed. But it's already been on my skin, it travels around. And so then I got it in my pelvic region.
Is that what happens?
And
once it's in your skin?
Well, we've got all this stuff, yeah. Once you get one, even if it's not MRSA, whatever this, the staph, Staphylococcus aureus or whatever it's called. It's all in your skin, and I think it also depends a lot on your immune system fighting it off. And I got this in grad school. I was under a tremendous amount of stress. I was so stressed out. I wasn't sleeping because I had, I was just working. I was just working, and stress, big time. It was I was getting sick a lot more often than it was just a bad. I had IBS, bad part. Anyways, so then I got another abscess in a different region. It was closer to my pelvic region. And they gave me some antibiotics orally, and then also some of this stuff called muprosin, a topical antibiotic. And, it would go away and then come back. And it did this, I got antibiotics again. It did this twice. And at that point, it was what the hell? This isn't working. And I started looking into the literature on, okay, is there like a combination of things I can do to potentially help impact this, right? And so, you can find all sorts of things. There's all sorts of compounds in various herbs and essential oils and things like that. And so after doing a lot of reading, I'd come up with some of the major ones were garlic. And this garlic was both topical and oral. I was also taking like oral vitamin C like once an hour to kind of help boost my immune system. I don't know, whether or not that did anything, but that was part of my protocol. And then on topical, I put garlic, so I would open up one of those garlic pills, and then I did tea tree oil. That was a big one that was showing to have like an effect, particularly on MRSA. And so I was putting tea tree oil, and then I was also taking grapefruit seed extract orally because that was shown to have an effect. And I was taking EGCG, which is like from green tea. It also was shown to have like these are all, studies in vitro showing it has an effect on staph MRSA. Grain of salt. It's like, okay, in vitro, you put it on it. It's like it kills it with a dose of X.
Can you explain in vitro to people that it's just cell culture?
Yeah, so you basically put something in cells that are in a petri dish. So it's hard to extrapolate something like that to a human. But I was desperate. And, it was like, okay, well, I'm just going to, and I was taking this stuff, like the oral stuff, like the garlic and the grapefruit seed extract. I was taking it like every 1 to 2 hours.
Is there any benefit to taking fresh garlic versus taking it in a pill form, or even like using it as, like you were saying, you took the capsules? Would there be benefit in taking actual real garlic?
Well, real garlic is great too. And once this thing went away for good, I was like, oh, garlic is the bomb, so I would eat garlic anytime I would feel any sort of sick or anything like that. But the oil is highly concentrated. You know what I mean? You're like smashing down all the oils from the garlic.
So they're a capsule?
It was a capsule with oil, garlic oil.
Okay.
Yeah,
it's not powder.
Garlic oil. No, it's not powder. Yeah, it was garlic oil that I was doing at the time.
So you'd cut open the capsule and just put it on the abscess?
I would cut it open and I would put it on topically, and it didn't smell good, along with the tea tree oil. But I was like determined. I was like, I'm going to try this. I kind of am that way. Like when I try something, I'm like, I'm going to try it. Like I'm going to really give it a shot. Like I'm going to do it. And so I was like, yeah, I stink, whatever, deal with it. And it worked.
How long did it take to clear up?
Really quick. I mean, I think my memory was something like 2 days for me to notice. Like 2 days, it was like, it pussed out. So like the abscess, like it like pussed out, and like literally within like 2 days, I think. Something like that, where it just, instead of just being this abscess that's not coming to a head and hurts. And
I started getting a patch of folliculitis from jiu-jitsu, which a lot of times people associate with staph. When you see those little red bumps, like where your hair follicles are, it was on my leg. And I got pretty sketched out by it because I've had staph in the past. But I killed it with topical spray. There's Defense Soap, which is a company that makes products specifically designed to prevent fungus infections for grapplers like ringworm, and help prevent staph infection. All their stuff has like tea tree oil, eucalyptus oil. It's all like very healthy. And they make like a spray for specific issues like that, when you have like a topical irritation and like something that's on the surface of your skin. I managed to kill it, but I was nervous because I've had staph twice, and I was like, oh fuck, here it comes.
Right. And it could, it's like, and it could be serious. Like it really could.
But I jumped on it quick, and within a few days it was gone.
I've gotten folliculitis once. I had, when I was in grad school, I was trying out that like Indian threading of your eyebrows or whatever. And
what?
Have you heard of this? It's like they do like, instead of like plucking them with the tweezer, I've got these Italian eyebrows, and they're like thick. Really.
How big do they get?
It's been a while.
Do you get a uni?
No, I don't get the uni part, but it's like down on my eyelid. Anyway, so I was in grad school, and there was like a woman from India. She was in my lab, and she was like, this is the best thing. It's like, it's so much better than plucking them and whatever. She convinced me to try it, right? So I went to some place, and they do this like thread, and they like get the hair and like do this thing where they like put it around the hair and pull it out. And it's supposed to be. I don't know what all.
How's that better than plucking? You're plucking.
You're supposed to like they get it like at the root more, and they get I don't know whatever. I got fucked up from it. I got folliculitis, and it was like I had a rash on my eyebrows. Like it was awful. And of course, me and my tea tree oil, like especially at the time, after I had like had that, staph infection, whatever it was, go away. It was like tea tree oil, anything, any bump, is it, whatever, tea tree oil.
Right.
Now I'm actually, to be honest, and it did help, by the way, but there's these studies coming out with tea tree oil, like causing, like changing hormones and like estrogen mimicking. And so now I'm kind of like, oh, not too much tea tree oil.
Estrogen mimicking, meaning it'll elevate your estrogen?
Like mimicking the biological action of estrogen.
Oh,
and so,
boy.
Like, it's called, have you heard of like some of these guys getting like gynomastia?
Yeah.
What's it called?
Gynomastica, yeah.
Yeah, gynomastica. Where they got like boobs and stuff.
They get man boobs.
Yeah. Well, I think there's some evidence linking like crazy tea tree oil use to that too.
How much tea tree oil are these guys using?
I don't know, but this stuff, I mean, it gets into your system too,
So maybe like they're rubbing it all over their body.
I don't know what they're doing.
Fucking hippies. They ruin everything. Even good things.
Yeah. So I've sort of now it's like, okay, the tea tree oil comes out. Like if there's some little bump, it's like, okay, I get tea tree oil, but I'm not like I'm like not crazy about it now. It. Right.
Yeah, makes sense.
So
Yeah, I think gynomastica though is like pretty extreme. I think when guys get it, it's usually, if it's not from some sort of strange hormone imbalance, it's usually from using steroids. Because they use steroids and they take so much testosterone that their body expresses. I don't think it's just estrogen. It's something else too. There was actually, I was watching a video on it. It is horrific when they remove it. Oh my God! It looks like the little thing from Alien that comes bursting out of your chest. I thought it would just be fluid. It's not fluid. It's a mass. Ugh. It's a big,
like a tumor?
Thick, meaty mass. And there's videos of guys getting their gynomastica removed. It's basically like there's a whole culture on YouTube of like these steroid guys, that like show all the damage that they've done to their body through steroids. And one of them is guys that have had their boobs cut open to take out this gynomastica. And it's just these big, pulpy looking. Pull it up, Jamie.
I was trying not to, but.
Trying not to. How dare you?
I don't know if I want to see this.
You need to see it because it's crazy. Because people need to see it because.
Is it fat?
Yeah,
is it like?
It's I don't know. It's some kind of breast tissue, but it's breast tissue like a boob, like an actual
I've seen them before. Yeah, I mean they look like it for sure.
Yes, yeah. There was a guy who fought in the UFC way back in the day who had it, and he had it bad, and then he got it removed, and then he looked normal after it. But I mean, he had like boobs.
That's the only one I could find with the thing.
Yeah, but that is nothing. That's just holes. If you could show a video of them, see that stuff in the right-hand corner? That's it. That's what it looks like.
Ooh.
Yeah, click on that. Like, that's what it looks like.
It does look like fat.
It's like these giant glands. Yeah, right there. Gynomastica, huge glands. That fell in the middle. Oh, look at that. I mean, these are huge things that they're pulling out of these guys' boobs. Yeah. There's another, it's not just estrogen that's causing this. It's something else.
And I don't think, by the way, tea tree oil is the only thing causing it either, to be clear.
Well, especially something like that.
Yeah,
I'm pretty sure that is, unless it's like coming from some strange, weird hormonal imbalance, just it's a natural irregularity, irregularity of the body. It's coming from steroids. It's very common with guys who've done a lot of steroids.
Wow. They
have to do a lot, though. You have to you get crazy, and then these things grow.
Yeah.
But they are boobs.
But yeah, they definitely are.
Yikes.
Lavender oil is another one that's been shown to have like the hormone disrupting effects. Yeah, so like.
That makes sense because that's like associated with ladies. Like ladies putting the lavender oil on, right?
I know is lavender, I mean, it kind of has this calming effect, like aromatherapy, you breathe it in and it's. Do you ever put lavender oil in the sauna when you're in there?
No, I do eucalyptus though. Yeah.
Well, that's like helps you breathe, but there's the lavender.
Does it help?
Well, I mean, it seems like it, yeah. Yeah.
I have become absolutely obsessed with sauna use over the last, like, I guess it started because of you. And then over the last, like, through the pandemic, the last year and a half or so, I'm in every day, every single day. Like, it's very rare that I take a day off. I mean, I have to be wrecked to take a day off of sauna use.
Damn,
Like,
you're getting all the benefits.
yeah. Even when I come home at night, like last night I had a show and I'm out with all these fucking weirdos with no masks on. So I'm like, as soon as I got home, I cooked myself. I cooked myself for like 15, 20 minutes at 185 degrees and just deep breaths. And, you know, there's that paper that I sent you about COVID-19 and, you know, the therapeutic intervention of using sauna. And this idea that when your body heats up like that, like you're trying to kill off a virus when you're sick. If you're sick with a viral infection and your body gets a fever, your body is trying to kill that. And this idea, this paper is, you know, exploring the use of sauna to intervene, to stop it from ever infecting your body, both through your nasal passages, through your airway, and also just through the actual heating of the body.
Right. Yeah. There's a fever response that is induced, like when you have an infection, and part of that is to help fight off, you know, the pathogen as well.
Because the pathogen can only exist in a certain temperature range, right?
Partly, yeah. I mean, there's multiple mechanisms. It also activates heat shock proteins, and heat shock proteins have a role in your immune system response and how your immune system responds. So it plays a role, particularly in innate immunity. Which is the kind of immunity that is important when you first see a pathogen that you've never seen before. This isn't like an antibody type of response. It's like killing of it, you know, before that. But there's interesting evidence, I'm sure we've talked about this, coming out of Dr. Jari Laukkanen's lab in Finland. This was a few years ago where he looked at sauna use and like incidence of pneumonia. And people that so in Finland, saunas are ubiquitous. You know, most people have one at their house. Most people use it at least once a week. But then you have people that are using it like 2 to 3 or 4 to 7. And so he always kind of stratifies the data based on like frequency of use. And he found that people that use the sauna 4 to 7 times a week were 40% less likely to get pneumonia. And this was after like correcting for all sorts of like other lung diseases and other health factors and exercise and all that stuff, you know. At the end of the day, it's a correlative study, right? I mean, but I thought that was interesting because there's also like all these other studies that have been done in like the 80s looking at the effects of the sauna on the lung function and like helping with, you know, like a variety of factors of lung function. So it's interesting. There's probably like lots of things going on as well. And as I just gave you my paper today, was published with my co-author Teresa Johnson in the journal Experimental Gerontology. We argue that if the title is Sauna Use as a Lifestyle to Increase Health Span, which basically refers to the disease-free part of your life. So in other words, you know, like as you age, you become more susceptible to things like, you know, cancer, Alzheimer's disease, heart disease, respiratory problems, all that stuff. And so we argue that sauna use should be up there with things like exercise and good sleep and good diet, you know, things that are known to improve your quality of life. There's just tons of evidence, things that we've talked about before, but, you know, talking about the cardiovascular disease improvements, how sauna. But one of the things I'm most excited about, like I've been getting my mom in the sauna and she's been sedentary, you know, like her whole life, basically. She's overweight and like there's no getting her on a Peloton. There's no getting her to go for a jog. Like it's just not going to happen. Maybe once, but like it's just not going to happen. And so I've been trying to get her in the sauna because I'm trying to improve her health some way, right? And, you know, it's a lot easier for people, at least I've noticed with my mom, you know, views it as like a spa treatment. You know, she goes in there and puts some cold water on the hot rocks and it's kind of like a steam room. Like she feels like it's a spa. But she's also getting, you know, the sauna mimicking moderate cardiovascular exercise. Like that's what it does. And we talk all about that in the paper. But, you know, so people that are like sedentary and have been sedentary their whole life and also people that are disabled. Like there are some people that can't go for a run. There are people that can't even get on a Peloton. Like they're disabled and they can't do aerobic exercise. Like this to me is like a no-brainer.
Yeah.
A no-brainer. I mean, granted, there are some contraindications, like if you have certain, particularly certain heart disease risks, that could be a contraindication, meaning you shouldn't do it. But by and large, it's improves a lot of cardiovascular things.
Can you mitigate those risks by having a slightly lower temperature, like instead of like going to 185, maybe going to 160 or something like that, where it's a more mild form of heat?
Right. I don't know. I know that to me that would make sense, and you have to discuss this with your physician. But for example, people that have arrhythmias, there could be a very mild contraindication with arrhythmias, and so the question is, would a lower temperature like 165, which is what I've been doing for my mom, mostly because she's not adapted to the heat at all, and so you have to adapt before you can do 20 minutes at 185. It takes a while for people that aren't used to even raising their core body temperature when they're exercising.
Mm-hmm.
So again, it's mimicking a lot of the physiological aspects, including that core body temperature going up. The blood flow changes going to your skin and sweating. Heart rate, your heart rate is elevated while you're in the sauna, and then blood pressure goes down after. These things have been compared head to head. So it does mimic moderate aerobic activity, and it's the only way that I'm able to get my mom in there. And then there's the brain benefits, and this is something people that are depressed. Like my mom actually she's been diagnosed with major depressive disorder, and you look at she's got a variety of SNPs there are certain SNPs that she has that are, consistent, like in the serotonin transporter and things like that. You can look and see there's evidence that she has things that have been linked to major depressive disorder. And also she's had a lifetime of being inactive, and there's a lot of environmental factors at play, like drinking Cokes, refined sugar, that's inflammation. But there's been some evidence from Dr. Charles Raison. He was the first to show that a single, what they called whole body hyperthermia, which is basically they were using this really expensive device to elevate people's core body temperature to 101 degrees Fahrenheit. They were doing a fever. They were getting hot. And they had a sham control, people that they were elevating their core body temperature a little bit, so they thought they were getting the treatment, but they weren't. So it was.
How are they elevating the core body temperature?
It's kind of like it's called the Heckle device. It's this crazy thing that it's kind of infrared-ish, where it's doing it through that, what an infrared sauna would do, basically. Mm-hmm. And so they did this in the people that were in the sham control group, which is kind of like the placebo in a way. And so 70% of those people in that group actually thought they were getting the treatment. So it was a wonderful placebo. Because with anything depression, placebo effect is a very real thing. And people know they're getting a treatment. They're going to feel better. Yeah, this works, So it's important to have that control. And they showed just one exposure to this. There was a huge antidepressant effect that lasted 6 weeks.
What? One session?
One session. And the mechanism for this is completely unknown. We talk, Teresa and I talk a little bit about this in our recent publication, but it's also a topic page on my website. It's the sauna, we have a 20-something page, article that is a lot of this on the website. But part of it could be there's a million things. So here's the thing. There's so Dr. Ashley Mason, she is at UCSF, and she specializes in non-pharmacological treatments for depression or sleep. And she actually trained with Dr. Charles Raison, and she sort of carried on the torch. And I'm collaborating with her now, which is really cool, on a clinical trial where she's basically taken, forget that device. It is $50,000. It's all this FDA tape and to get it and use it. And so she's found a way to basically get an infrared sauna where people are laying in this tent with their head out, and they're in there for a long time, and they're measuring their rectal temperature and making sure they get up to 101, and it's a silicone probe. It's really easy to it's not uncomfortable, but these people are getting hot. They're getting so hot that technicians are having to like cool them down with wet towels, and like while they're in this thing, because they have to be into that degree where they're getting like a
So
fever.
they're cooling
response.
their head? Is that what
They're
doing?
cooling their head. Yeah,
Okay.
but she's done a proof of principle study on people that are not depressed that shows that it's like not dangerous. Basically, it's not dangerous. People will do it, and that's kind of like you have to like show that before you can like go on to the next step and use it as a potential clinical treatment for depression. So now the study that she's going to be starting any day, which I'm collaborating with her on, is she's going to be recruiting clinically depressed patients or participants and giving them this treatment. And it's going to be a dose escalation. In other words, she's going to try to do it at least 8 weeks. Like I mentioned, the first one was one time. So once a week for 8 weeks. So they're going to be, see if they can even do this, like if they can handle it, right? And she's going to combine it with cognitive behavioral therapy, CBT, because that's a known treatment to help with depression. And you can't start any study without giving like a treatment that's known to work because it's like unethical. But what I'm excited about is the biomarkers that we're going to measure, like, brain-derived neurotrophic factor. That's been shown to play a role in depression. And it's one of the major things, like exercise increases it. And there's been studies showing hot baths increase brain-derived neurotrophic factor, BDNF. So, it's like, well, let's see if the sauna is doing that. Like that would be one potential mechanism. And then there's a variety of other, we'll mention heat shock proteins. They've been shown to play a role in mood in animal studies, and a variety of inflammatory biomarkers. Because what was interesting about that pilot study by Dr. Charles Raison was that he found the people that had the most robust antidepressant effect had higher levels of something called IL-6. IL-6 is a cytokine. It's kind of often referred to as like a Janus cytokine because it's like both pro and anti-inflammatory. It has like both effects. It's something that is elevated when you exercise. And, there's a robust anti-inflammatory response in some cases, like IL-10 and things that are anti-inflammatory. Anyways, he found people that had the highest levels of IL-6 tend to have the most robust effects of the sauna. So a variety of interesting things, super exciting because, if this could be a potential treatment, getting people, and like I know you and I have talked about this like probably a million times, but like getting depressed people to go exercise like is not easy.
Right.
Like they don't have that motivation.
Yeah, I've experienced that.
So
many
like
times.
imagine if you could just put them in a sauna, right?
And it would have a similar effect.
In theory, we don't know yet. I mean,
How much body what do you think your body temperature is getting to if you're at like what I do, which is like 185 degrees for 20, 25 minutes? It gets rough.
Right.
Especially at 25 minutes. The last 5 minutes are really hard.
Yeah, so I asked Dr. Mason about this because she's like gone around into different like banyas and stuff in San Francisco and like had her friends like trying to like get the rectal thermometer and see like do this or do that. The problem is like,
People don't trust you at a sauna with a rectal thermometer. They're like, hey.
Yeah, I definitely agree with that. But she said she couldn't get, there was nothing out there as intense as that. Like, most of these
As
like
intense as what they're
165. As intense as what you're
I'm
saying.
doing, yeah.
And it's kind of what I do. So I do like 185, like 15 to 20 minutes, depending on if I
You've done
exercise.
it at Laird Hamilton's house, right?
I've done it at, not yet. We've been like planning. I've done it at Rick Rubin's. And,
okay.
But his sauna was like 200 and something. And then he had this like ice bath.
Yeah.
Outside of the sauna, and we were doing back and forth, and like that's the closest thing you're going to get to a psychedelic experience without doing psychedelics, in my opinion. It's like crazy. It changes your. I mean, have you done that before?
The back and forth, yeah.
Yeah,
Today.
like intent. You did.
Yeah, I have an ice bath. I have an ice bath right next to the sauna. I do it every day.
What do you think? I mean,
It makes your whole head dizzy.
It does.
You go shaking back and forth.
It does.
One thing I found is I can't stay in the ice bath as long after I've gotten out of the sauna, which is really odd because I almost feel like I'm going to pass out. Like when I get to like 3 minutes in the ice bath after 20 plus minutes in the sauna, like my vision is shaky.
Okay, so here's my anecdotal story. So I was doing I was scared of ice baths for a long time, like for months because of this. So back in the winter when before we had a cold plunge, we were using the pool because the pool was cold in the winter.
Right.
It was like,
Not
50
heated.
degrees. Yeah, which is
Cold.
cold. It's cold. Like it's not ice bath cold. Like that's
Yeah.
insane, but it's cold. And so this time I was in the sauna. I was in the jacuzzi. I was in the jacuzzi for like 20 minutes, maybe 30. Like, I was getting my heat stress on, right? And then I went into the pool. And, I had my Simon and Garfunkel on. I was like singing. I was trying to stay in there. It was cold. And it was burning. It was burning. But I was in there for just not more than 5 minutes. Like it was, and all of a sudden I started to get really blinky and dizzy. And I was like, ooh, I don't feel good. So I got out of the pool and I got some kind of vertigo or something. I couldn't stand. I had to go down to I felt like I was dying. Like I had to go down low to the ground. And Dan was assuring me it's okay. And this lasted a couple of minutes. I was terrified. I was really terrified. I guess it was kind of a vertigo. I didn't know what was up or down. I couldn't stand because it was and I felt like my blood pressure maybe was really low. I don't know what caused that. I don't know if I had gotten cold water in my ear. There's some you can read some anecdotal stories about cold water swimmers that wear some kind of earplugs because it can give them vertigo. I don't know.
They develop bone matter in there. Do you know that?
No.
Surfer's ear. Yeah, a lot of them have to get operations on it, on their
crazy.
ears. Yeah, there's something that happens to the inner ear. Find out if you can find what that is. It's called surfer's ear. A friend of mine got it.
Does that affect the balance and stuff? Does that give you
Think
vertigo?
so. I'm not sure. I've never surfed, but I know that there's some sort of bony thing. Oh, here it goes. Surfer's ear is a condition where the bone of the ear canal develops multiple bony growths called exostosis. Over time, this can eventually cause a partial or complete blockage of the ear canal. The condition is primarily caused by prolonged exposure to cold water or wind. Interesting.
Yeah.
So you see those little weird bony growths in the inside of the ear. It's almost like your fucking skull's trying to protect you. Oh, that is so nasty. Inside of ears are so gross. I got a little a thing I bought on Amazon. It's a camera that's attached to an ear cleaner. And you have an app on your phone, and you could actually stick this thing in your ear, and you could see the inside of your ear. It's wild.
Oh.
It's wild.
Yeah. I wore earplugs on the plane yesterday, and when I took them out, I was disgusted by the ear. I don't know if I want to see more in there,
Yeah, you can clean it out, though.
Yeah, I know. I've got really small ear canals, and I get problems with that. And also, earplugs hurt me because my ear canals are so small. I have to get the baby ones, or I need to try to get the custom made ones because I can't wear that. It hurts. I can't sleep with them because it hurts.
I wore ear guards all throughout my years of doing jiu-jitsu. Pretty much every time I trained. I have very little cauliflower. I have a tiny couple of little pieces. But I have friends whose ears are fucking mangled. And they love it because it makes them look like a badass. Ooh. It's a jiu-jitsu thing. Guy and wrestlers, it's a wrestler thing too. It's almost like a badge of honor to have really fucked up ears. But I have friends that they don't AirPods, Apple ones, they don't fit in there. They can't even go in. Their ear hole's so small. I'm like, what can you really hear with those goofy ass mangled ears? Because if you take your ears and you just go like this,
yeah,
and then you talk, and then I'm folding my ear, and then go like that and open it. It's very different between what it sounds like this and what it sounds like this. So they're their whole life is the reason why your ear is shaped like that is so that you can kind of capture sound, right? It's good. It makes your ear work better. Their ear is constantly clogged.
On the flip side of that, they're probably less likely to get the noise-induced hearing damage that happens with old age, but they can't hear anyway. So then
Do you know if they have tried? Any of those guys have tried out the jaw conduction headphones that don't go in your ear?
Where do they go?
They go around your head, sort of. They just don't go in. You've probably seen them, but you may have never tried it. It's a very strange feeling when you test it out.
You use those?
That one CES thing, I tried it out there just because it was new then. It was like 2017.
Did you like it?
It was weird.
So you hear music like clearly?
It just vibrates on your bones instead of into your ear. It vibrates on your bone and gets into your head, which is like, when you're if you're in the shower, you do exactly what you were just doing. You can still hear the rain hitting your skull. It's just you're hearing,
weird.
or the water. I'm sorry. It's just different.
Huh.
But I'm way curious onto someone who has that ear problem if this creates a better experience or if it's just like, yeah, I can hear it now finally.
The smart guys get it operated on. Like you really should drain it right away. But I know quite a few friends who've had their ears operated on, where they literally fillet your ear and then they cut out all the calcified blood, which is what it is, right? It's like blood pools up in the tissue of your ear and it becomes calcified. And then they have to cut that out.
Now I'm learning new things.
You didn't know about cauliflower ear?
Not really, no, I
Really?
didn't.
You want to see it? Show her photos of cauliflower ear. Just what it looks like. Just cauliflower ear. Because it's nasty. Like, and 80% of my friends from jiu-jitsu have it.
That's crazy.
Yeah, they all have it. Yeah, that's what it looks like. Look at those ears. Look at his ears.
Wow.
Yeah. That's Khabib Nurmagomedov, one of the greatest, if not the greatest of all time. Randy Couture, his ears are mangled. Look at that dude. Look at his ears.
That's so disgusting.
Yeah, that's all hard. That's like a rock, too. The thing about that is it's calcium. So the inside of it is...
How can you hear anything with that
You don't
ear?
hear much. You don't hear much. Yeah. Look at that one. Okay, yeah.
Is there balance off or anything like that? Are they like, does that like, no?
I don't think so because it's not really an
not
inner ear issue, but the outer ear is just horrific.
Gosh.
Yeah. It's pretty gross. And so what you should do, what a lot of guys do, is they'll get a syringe, and right after it happens, like literally I've seen guys do this at the gym where they have a buddy stick a syringe in their ear and suck the pus and blood out like at the gym. You know, they just have this thing and pull it. Like, see if you can find a video of a guy. Yeah. Because it's amazing how much fluid comes out of a cauliflower ear.
This
So
is like the
guy's
Fear
got it.
Factor Joe coming out here.
So this guy's doing it. He's doing it to himself. So he's pulled out that much blood. Oh, okay. And so he's pulling this. So he sticks it in there, and once you get it in there, you really should go low. He's going high, but you really should go low so you get all of it in there. And then see how it sucks it out and drains it? Now look at all the blood that's in his syringe. That is all stuff that would have calcified. So most guys like it because it's like, let everybody know, oh, he's been training. Look, his ears is badass. You know.
Wow.
I think it's dumb.
That's crazy. Totally. Yeah.
I only have like a couple. I have like a little bit of it here and some other spots where it calcified, but it's very small.
Good thing you were wearing those ear
Yeah,
protectors.
they're annoying. They get in the way. Like these things, they're under your chin, they're on your ears, but it just keeps your ears from getting fucked up.
Right. I mean, it's annoying to wear a helmet when you're like riding a bike, but it's protecting your head. I mean, you know.
So what happens to me is I can go in the ice bath, and I thought I went in the ice bath once for 20 minutes, and I thought I had fucked myself up. I thought I broke something because I went in afterwards, and like I was like at like the 3-minute mark, my visual field was shaky, almost like I was really drunk, and I was like, this is not good. Let me get out of here. But I realized that that's actually just coming from the sauna. So going from the sauna to the ice bath is very shocking to your system. It's probably good for you overall, but it does this weird thing where like everything feels like shaky and back and forth and weird. But if I just go straight in there, it doesn't do that. I can just go straight in there and then I'm fine.
So you took the words out of my mouth. So that was like I was trying to get to the bottom of this. Like I had been in the jacuzzi for like almost 30 minutes, and I was like heat stressing myself. But I was still terrified to get any cold because it was so scary. So I didn't do any cold at all. And now what I do is I just do, if I'm going to do the cold, like I did like a 7-day challenge like recently where I just get in Dan does this thing, like he gets in, we keep it like 49 degrees Fahrenheit, and he gets in for like 12 minutes. I mean, he's just in there, like he loves it. He does it like first thing in the morning. Sometimes he does it before bed, helps him sleep. I can't, like, I'm like in there like 1 minute, and I'm like, because I'm just not adapted, like I'm not adapted, and I don't have as much brown adipose tissue, which, is a good thing but you lose it pretty quick. Like Dan didn't do it for a while, and he like, it was harder for him to stay in for that long. But, when you are going, and this is something like I've talked to Jari Laukkanen about this, going from the hot to the cold. So in the hot, you have vasodilation happening, right? So you're relaxing your blood vessels, blood flow is increased. When you go into the cold, vasoconstriction happens. Like it's the opposite. So you're going from like dilation to constriction. And like, a lot of what regulates that is norepinephrine, which is a hormone and also a neurotransmitter, depending on if you're releasing it, if it's being released in the plasma versus in the brain. But part of what it does is cause vasoconstriction. And it's, there's just not enough research that has been done on going from the hot to the cold. And certainly not going back and forth. But in Finland, like at least 10% of the population there, of the people that are using saunas, do that. Like they do it frequently. Not everyone does it, but like a good percentage of people do it. Like I've gone over to Finland and done it. So there's just not a lot of evidence. And, on the one hand, like you can feel really good, but like there's an amount of stress that, I mean, maybe it's just something from going from the hot to the cold and regulates your blood pressure, right? I mean, I don't know. But so now I don't do the cold after my sauna because of that. Like I was just been scared.
I do it, but I just do it for a minute. That's how I do it. I did it for 3 minutes yesterday. That was a long one for me. Generally, no, 2 days ago. Yesterday I did a minute. I'd like a minute. A minute is what I like because I get so hot in there. And a minute cools me off and I get a little weirded out, but not crazy. But when I did 3 minutes the other day, at the third minute, I don't like the way I feel. Mm-hmm. I just feel like I got to get out of here. Like it just feels like I don't know if I'm going to black out, which sounds crazy.
Right. No, totally.
But when I did 20 minutes, I did 20 minutes at 33 degrees.
Without any hot?
No hot. Never felt like I was going to black out. It was just really cold.
That's interesting.
Like my visual field was completely stable. Like because I put
blinky stuff.
None of it. But then coming out of the sauna, it's super shaky.
I had the blinky stuff. Yeah, I had that.
Like I'm drunk.
Totally. Like in my case, it was pretty severe. It was like I felt like I was dying, and it was very scary.
Well, mine was a little weird too. Like the first time I did 3 minutes after the sauna, I was thinking, I think I broke myself when I did 20 minutes. I was like, maybe I really fucked myself up. Like maybe that's not good. But then I realized, no, what it was is I did 20 minutes after a workout, but I wasn't that heated up. Like I'm pretty sure that workout was just a weightlifting workout, which is not that bad. I sweat a little bit, but it's not like the real ones are like kickboxing workouts. When I do I'll do 10 rounds on the bag. And then when I'm done, I'm drenched with sweat. I mean, just my T-shirt is completely soaked. My underwear is soaked. My shorts are soaked. I'm really heated up. And then I'll go in the cold. It's rough. But if I go in there just right now, like if I just sunk in there right now, my visual field would be fine.
Yeah.
But coming out of the sauna, it's a weird shock. I don't know if it's good for you.
There needs to be research on it.
That's
really,
the problem.
It is. And so hopefully...
But everybody tells you should do it. Right? They're like, oh, yeah, you go back and forth from sauna to cold. But I think they're doing like 10 minutes and then a minute, 10 minutes. I'm an extremist, right? So I'm doing 25 minutes and I'm at 190 degrees sometimes. It's,
that's intense. Yeah.
It's a lot. And
right.
So I'm really hot when I get out, where I'm like really barely hanging on. And then I go plunge right into 33 degrees.
Well, here's the thing. Right after the sauna, so one of the things that the sauna does is it lowers blood pressure. So while you're doing it, your heart rate's elevated and your blood pressure goes up while you're doing the same thing with exercise. But after, like pretty immediate after, blood pressure goes down. And this is like one of the reasons why it's so cardioprotective, among others, is that it really helps regulate blood pressure. But if you think about it, if your blood pressure's already dipped down below baseline, studies showing that's what happens with the sauna, then you get into something that's vasoconstricting, right? I mean, like, it's got to be like a crash in blood pressure. That's, I mean, that is something I was thinking. And, it's just, we need evidence to show that. We don't know what it is, but something's going on. And it's interesting that you've had the same effect that I did somewhat. Mine was definitely scary, and maybe
mine was a little scary.
Yeah,
I was like, because I'm by myself. Because I
yeah.
like to work out by myself, and when I'm doing this all by myself, I'm like, hey, don't die, stupid.
I know.
This is a dumb way to die.
Yeah, totally. Yeah, I was like,
but 1 minute is great. 1 minute feels really good because 1 minute's easy. I have no weirdness to the visual field. I do 1 minute, I get out, and then I get back in the sauna. And the sauna at 190 degrees or whatever it is, it feels like nothing. Like nothing. It feels great, and it feels really relaxing. It feels nice. And then I start to sweat again, and then I get out. I don't do too many. I don't go. I've done it a couple of times, but I like just one. I just like sauna, ice bath, and then sauna until I heat up again, and then back to normal.
That sounds a little more
reasonable.
Doable. Yeah, reasonable. Exactly. So I personally like doing the cold without anything, and for me, like 1 minute. And I feel good. I feel good after. Could be the norepinephrine's been shown to go twofold over. I mean, I know a lot of people do it. Like Dan does it. Like he really is into it. Like big time. Like just doing it alone, and it's like helps him feel good. Helps his mood. He doesn't.
I think it's addictive.
Yeah.
I think there's like a weird feeling, like a state change. Like because I feel that with the sauna as well. It's very like I feel like when I get in, I'm like, oh, I get my fix. I feel that when I climb in there.
Well,
like,
you make endorphins.
It.
You're dumping out endorphins in the sauna.
Yeah.
I mean,
it's also like I used to listen to a lot of books on tape in the sauna, but now primarily I do it just nothing, and it gives me like a time to think, like just to reset, time to think and just relax, and I'm enjoying that a lot. I'm just enjoying the opportunity to do nothing.
Yeah.
And just sit and think.
That's what sometimes I'll do a podcast because I never, ever, ever get to listen to anything if I don't. But the majority of time for me, I sit and like, it's like my time. It's like my time to like reflect.
Yeah.
Sometimes I'll even like rehearse things like a presentation or something. And like, I've done that for a long time. I've done that like since grad school.
I'll listen to sets, like comedy sets that I've done because it'll help me like tune in for the next one. Like I was doing that a lot in the middle of the pandemic because I wasn't doing much stand-up, and then I would have to do a show. And so I would have to listen to old shows and sort of remember my material and get the beats and the rhythm. Like you don't want to just go on stage completely cold. You can look at your material. That helps a little bit, but I felt the best way is actually listening to a few sets, not even just one, but two or three.
Wow.
Yeah.
That's got to be, I mean, you're so experienced now doing that, but like I like listening to myself. I don't do it anymore. I mean, time, everyone's excuse, but when I go on a podcast, like when this is my 10th time on this podcast.
Is it really?
Yeah.
Wow.
It's my 10th. So like I would go back and listen to, this was like back when I was, first coming on, I listened to it. Oh, it was so hard. It was so hard. But like you learn about like the mistakes that you, like things you could do better. It's really like a way to improve in this aspect, your public speaking.
Yeah.
And the way you communicate certain things and how you shouldn't communicate them maybe, and not talking over someone, like that's a big one for me.
Yeah.
Like, and you really, like, unless you sit down and listen to yourself, you're not gonna, like, it's not the same. Like, you're just not gonna know.
That's why I make people wear earphones, or I suggest earphones. You don't realize what it sounds like when you're talking over each other in a recording the way you do when you have earphones on. Like if you have earphones on, you hear it exactly how people are going to hear it recorded. But if you don't have earphones on, it just sounds like a normal conversation, and people talk over each other all the time. But you don't know how annoying it is to the person listening unless you have earphones on, because then your volume is the exact same volume as mine. So if you're talking at a certain volume and I start talking too, it's just noise. Whereas if you're over there and I don't have earphones on and you're talking, it's like your voice is lower and my voice is higher. I feel like, well, people can hear me better. No, they can't. You're just talking over that person. It sounds like shit.
Such a good point, and I probably should start doing that when I interview other people because
it's important.
You're absolutely right. I can't tell when I don't have the earphones on and I get excited about something and it's like, let me just talk. And hearing it at this level, you notice it.
The worst is if you have more than one guest. So if I have two guests and they don't have headphones on, it's just madness. I used to do these Fight Companion podcasts, and there was 4 of us. And I would do them. Sometimes guys didn't want to wear headphones, and it was just a talk over thing. They just talk over each other. I'm like, okay, we have to have headphones. You have to, because you have to realize how bad this sounds.
Right. Totally.
Yeah.
Well.
Yeah. So what else have you discovered? Like, what new information about the sauna, or what some new revelations?
I think mostly the new stuff is the mood, like the actual evidence on depression. But this review article is just a very comprehensive. You can't, people don't write review articles that are really comprehensive in a field anymore because there's no money, no grant money in doing that. It's a lot of work. And so you can't find a good review article that just covers everything, in a certain field, like with the sauna. There's review articles on the sauna and cardiovascular health, a lot of that. But this goes into the all-cause mortality, the cardiovascular benefits. It goes into the brain benefits and some mechanisms the effects on the opioid system. It goes into all these different mechanisms like heat shock proteins and, how there's lots of cool figures in there too, and how you can basically become heat adapted. And some of that has to do with you make heat shock proteins at a lower temperature. It goes into what special populations should be cautious when they go into the sauna and how long and what temperature and all that you get these benefits that are found in the literature. It's just a really comprehensive body of literature, I think. And so I'm just pretty excited about that. It's also open access to public, so it's not paywalled. So people can access this article. They can also go to my website where I have the topic page on it, which is this is a little different. It's a little more scientific, and we go into a little bit greater detail, and it has wonderful figures. But I think that's basically the gist of it. It's not necessarily something new so much as very comprehensive and covering the muscle mass effects. There's studies on sauna, helping preserve muscle mass, and we argue how that has effects for age-related sarcopenia, and that has to do with heat shock proteins as well. So we just go into all of that. And
I've noticed a benefit to my cardio. I've noticed it in doing it on a regular basis, that I just seem to have more gas when I'm working out. I really think that there's got to be a connection, because what I'm doing is I'm doing it after workouts. Like today I did a kickboxing workout, and then after the workout I do the rounds in the bag, and then I sit in the sauna for 25 minutes. And it does seem like it's more work. Like my heart is pounding, right? I get in there, my heart's pounding, I'm soaked with sweat, and then your heart continues to beat high because you're in this really extreme heat environment.
Right. There are studies showing that if you combine exercise with the sauna, you have even more improvement in your cardiorespiratory fitness than if you exercise alone, which cardiorespiratory fitness is it's a big indicator of your physical fitness, and it's also an indicator of your overall health. So there's additive effects happening with doing aerobic exercise plus doing the sauna. I also think there's potentially additive effects for weight training and doing the sauna as well, where you're basically you're not only with weight training, you're increasing your muscle mass, right? There's a growth of muscle, hypertrophy is happening, but with the sauna, it's really good when you're not doing that work, to basically increase your muscle mass. It's preventing it from degrading, which is a balance.
Now, there's a time after weight training where you should not get in the ice bath, right?
Right. So we just actually released a 23-page article on cold exposure on our website, and it covers all this. It covers things that we've been talking about, like norepinephrine, but it also covers this exercise training controversy, which I know I've talked about in the past. But yeah, it seems, and I like more of this needs to be worked out, but it seems as though like doing an ice bath immediately after strength training, resistance training workout, blunts some of the hypertrophy effects. And when I say immediate, it's like 5-10 minutes. I personally think, and this is a theory, it's a hypothesis, this hasn't been shown, but because the cold really blunts inflammation and it causes vasoconstriction, your immune molecules aren't traveling to the site like muscle as much as they would be, or so it's basically dampening inflammation. Part of the resistance training causes an inflammatory response. And this inflammatory response, including like activation of macrophages, which are a type of immune cell, is important for the increase in what's called IGF-1. It's a growth factor that you make in your muscle in response to exercise. It's important for, protein synthesis and hypertrophy. And so if you look at graphs of like the kinetics of IGF-1, it peaks after about an hour after resistance training, and then, starts to go back and normalize. And so I personally think that if you do cold exposure within that hour after your resistance training, you might be blunting that inflammatory effect that's important for the IGF-1.
Whereas the sauna would actually benefit you.
Yeah, the sauna doesn't do that. The sauna actually, like exercise, it actually increases inflammation. And, in this paper we argue that like there's a hormetic effect. In other words, like a little bit of stress is beneficial because then you have this anti-inflammatory effect. Happens with exercise, and some preliminary evidence, not like super big studies, suggests it also happens with sauna. So, it's a different thing that's happening in terms of cold versus a sauna.
So should you, say if you train weights in the morning, should you wait until the afternoon to do an ice bath if you were going to do it? Or should you do it on different days just to be safer?
I don't know. To be honest, we don't have any evidence to know for sure. I personally think that if you're waiting until later, like several hours later, you're already getting, your anti-inflammatory effect has already been activated through the inflammation induced by exercise. So can't see why doing the cold would then blunt that, because you've already gone through it,
Mm-hmm.
But without actual data, it's hard to know, right? It would be a hypothesis. I would think that it would be okay, to be honest. So, that's...
Well, through your discussions on this podcast and through many other discussions that have come out of that, I think there's been a giant rush, a giant change in the way people think of sauna and how many more people are using sauna. I can't tell you how many of my friends who never had any interest in using sauna before are now like complete sauna junkies.
Yeah.
It's really interesting.
It's awesome. Like I said, I think that paper, I think it's improving health span. And I think it's not just people that don't exercise. I think it's like you're getting a benefit if you also exercise, if you're already physically active, like an additive benefit. So that makes me happy. Plus, I also think there's lots of effects on mood and, but I also wish everyone could take the fish oil pill that we talked about, like, if everyone took it, then we might have a crisis with the.
They're not going to take it. You're never going to get everyone to take it.
Have you ever had
You
your
have to worry
omega-3
about
index measured?
I have, yes.
Do you know the difference between what the omega-3 index is versus like just measuring your omega-3? So omega-3 index specifically refers to measuring your omega-3 in red blood cells, and versus what most companies will do. They'll look at like plasma phospholipid. And the omega-3 index is important because it's a long-term marker for blood glucose. Your red blood cells, you accumulate it in the cell membrane, and your red blood cells take 28 days before they turn over. And so whereas if you were to have some sardines or whatever, like, and then go get your omega-3 levels measured, it could skew the data such that like, oh, I've got great omega-3 levels, because plasma phospholipids are kind of like the short term, like they're really responsive to your diet. Whereas the actual, it's kind of like HbA1c, long-term marker for blood glucose levels versus just measuring your blood glucose levels. Like, well, you could have just eaten, that's why they're high, and right. So like your HbA1c is like that long-term marker. So omega-3 index is kind of like that. Dr. Bill Harris and he had a collaborator, I forget his name, but they kind of co-invented this back in, early 2000s or something. But he argues that the omega-3 index is like predictive for cardiovascular disease, like as much, if not better than like cholesterol. And he's had a couple of interesting studies that came out on mortality. And looking at the omega-3 index, so like there's one study that he did was published last April, so a few months ago, and it was like 17 different studies included, and he looked at the omega-3 index. And he found that people that had an omega-3 index like above 7% versus like on the low end, which was less than 4%, they were 17% likely to die prematurely of all causes, including accidents.
What?
Like that's weird, right? It wasn't just like age-related diseases. It was all premature death causes. Like omega-3 is like making people not like take some kind of risk. I don't know. Anyways, I found that fascinating. That was the first study. Okay, so you're 17% likely. So if you're in that high group versus low, so higher than 7% versus less than 4%. You're also 21% less likely to die from cardiovascular disease. So that was the first study that was interesting, and the premature all cause thing was what got me. I was like, they're less likely to like get in some kind of crazy accident that causes them to die. So, as you and I know, omega-3 affects the brain. But the other study he just published last June or something, and it was the Framingham study, which is also a huge cohort, and he looked at the omega-3 index, and he found again people in the high end, like greater than 7%. They had a mortality. They had a life expectancy that was 5 years longer than people in the lower range, the less than 4%. And this was like after adjusting for all kinds of factors. Now remember, most people, they do these dietary questionnaires when they're looking at omega-3, like how much fish do you eat? Do you take supplements? Like they're measuring something. Like this is measured in your blood. This is a long-term marker. Like this is real data, right? So 5-year increase in life expectancy, like that's huge compared to people like, on the low end of the range. And in fact, in Japan, most people, what the average omega-3 index of people in the United States is like 5%. So you had to be slightly more than that, 7%, greater than 7% to have the, longevity benefits. In Japan, their average is like 10% or more. Omega-3 and mine was 11.7% because I take 4 grams a day of fish oil, 2 grams of EPA, 2 grams of DHA. But anyways, Japan has a 5-year life expectancy increase over people in the United States, where you're talking an average omega-3 index of 5% versus like 10. Interesting, right?
Yeah. Is there a plant-based version of omega-3s that's good?
Good-ish, yeah, there is. There's the microalgae. So, good point. Like the plant omega-3, like alpha linoleic acid (ALA), is like in flaxseed and walnuts and I don't know, something else, soybeans. But you have to convert it into EPA and DHA, and it's like that conversion's not very good. It varies a lot from person to person. And some of these benefits, like getting an omega-3 index of like greater than 7%, you're never going to get that from ALA. From just
never.
No way.
Really?
But you can take microalgae, and microalgae actually is the source of DHA and EPA in fish. Like the fish eat that, and it concentrates in their fat and stuff. But it's still like the microalgae pills like are not very concentrated compared to fish oil.
But what if you get pure microalgae? You can get some of that stuff where you mix it in water. Yeah,
you get like the spoonfuls. Mm-hmm. Yeah, you can take a lot more. That would be the way to go. That would definitely be the way to go. Get the stuff that you can mix in in whatever, or just take it like medicine.
It has to be refrigerated.
Yeah, definitely have to be refrigerated. There's lots of oxidation that's possible from polyunsaturated fatty acids, which EPA and DHA are. But a lot of the therapeutic studies, like they've done randomized controlled trials showing, that you can like drop cardiovascular death by like 25% if you give people with a various range of heart diseases, 4 grams of a purified form of EPA. It's called Vasipa. It's a prescription strength.
Say it again.
Vasipa. It's
Vasipa.
VASC EPA, and it is a high EPA. It's purified EPA, and you can get it prescribed from your doctor if your triglycerides are over a certain level. I don't know what that level is, but it's something that's like a prescription strength, which I actually want to get my mom taking. But so the what I'm getting at is the therapeutic effects for many of these cardiovascular related diseases happen at a high dose, where taking a microalgae and like I don't know how many spoonfuls, like how many tablespoons or whatever you're gonna have to take, but probably quite a bit.
That stuff's so nasty too.
I've never tried. I've tried like the Carlson's one like a long time ago. I used to take that, but that was fish oil, not microalgae oil, so I've never tried that.
Yeah, I've tried Carlson's fish oil. I've had that. The spoonful of stuff they have. Carlson's has like a bunch of different flavors too. They have like an orange flavor and a lemon flavor that's supposed to make it taste a little better. But I'm always a little reluctant because I'm like, what is that lemon flavor?
What's it masking, right?
Yeah.
Because when you eat rancid fish oil, it tastes like...
It tastes nasty.
Gross. It tastes disgusting. It smells gross. But
yeah.
There's a website called the International Fish Oil Standards, IFSO, and they sort of like they analyze data from lots and lots of different companies that make fish oil, and they give you all this data based on like concentration of EPA and DHA that's actually in the supplement, what's called total oxidation levels, TOTOX, and that's important. You want less than 10. It has the mercury levels, like PCB, so they have lots of data, and you can scroll through their website and look at each product sheet, and you have to kind of do it often because they update this, every so often. But I've put together, like I've gone through them all and made an Excel sheet on like all the different brands and like, again, like the concentration and the total oxidation and the mercury and all that. And I'm actually just getting ready to post a like screenshot video of me doing that like on YouTube, showing people and like what I think some of the top brands are. I have no affiliation. It's just me helping people try to analyze this data because they've said it like a million times on social media and people still don't know how to do it because it's kind of complicated. So hopefully that'll help people find some brands that have, again, you have to like, this is, you never know, each batch could be different too, right? So I think that's something useful as well.
What is the specific brand you use?
Well, I use one that's not available. Like a friend of mine in Norway makes it. It's called N-Pure 3.
It's not available.
It's not commercially available. Like he like sends it to me. Like he hasn't like scaled it. Oh. He's so big on not compromising the like total oxidation and all that. Like sometimes when you scale things up, things get compromised. And so I don't, he like is trying to figure that out.
So he doesn't sell it commercially?
No. I think he might in Norway, maybe. Like I think like he does do it in Norway, but the pandemic like shut stuff down, so I'm not sure like if he's back up or not. But he sends it to me, and it's like the highest quality fish oil I've ever. Like I could get you some if you want to try it, but it's really good. So they have high EPA and he has high DHA, and so I take the high EPA. I take 2 grams in the morning, and then I take the 2 grams of DHA in the evening. So I separate them. I don't know if it's necessary to separate them. There was some evidence conflicting in the literature. They're like, oh, maybe DHA, like if you take it at the same time, can compete with the EPA or, something like that. It's not really known. I'm not sure if that's the case at all.
What is the sources for the fish oil? Like what fish?
He uses herring and I think a mixture of another one as well. But his like contaminant level is like bottom out, like things of like arsenic, mercury, all that stuff is like really low.
Now, when we were kids, cod liver oil was something that people always recommended. Is there any science to that?
Well, cod liver oil is, the micronutrient it's most high in is vitamin A. It also has vitamin D and it has omega-3. I personally don't take cod liver oil because I think that omega-3s are I think they have a huge anti-aging effect. And this is not look, this isn't been shown, okay? It's just not how it's my opinion, okay? It's my opinion. So I'm trying to get high enough doses. If I were to take that from cod, I would overdose on vitamin A. It would be toxic because vitamin A, there's an upper limit. So I couldn't get that from cod liver oil.
What about in addition to? Is there a benefit in taking it in addition?
If you want to get your vitamin A and vitamin D through cod liver oil, you could. I don't think it's bad for you. You know what I mean?
But it's a way to get vitamin D other than the sun.
It is. But you can also take a vitamin D supplement.
But are you getting it in the same sort of, when you're saying you're getting vitamin D, are you getting 5,000 IUs? What kind
That's the thing. With the cod liver oil, I don't think the vitamin A concentration in every way always gets in the way for me. Mm-hmm. Where it's if I want to take 4,000 to 5,000 IUs of vitamin D, I'd be ODing on the vitamin A. I'd be toxic.
Got it.
So I just can't.
So you're better off taking a vitamin D supplement in addition.
In my opinion, yes, because I think having vitamin D levels between 40 and 60 nanograms per mil is optimal, and for me to get that for myself, I have to take 4,000 to 5,000 IUs. Well, depending on how much sun exposure. Sometimes in the summer I can go with less, but it really depends on the season.
And that was one of the initial factors that they found with people that were in the ICU with COVID, that a large percentage of them were deficient in vitamin D.
Right. Yeah. I mean, so the COVID, there are lifestyle factors I think that are important for possibly, helping with severity. And I think vitamin D is one. The problem is doing a clinical trial with someone that already has COVID and then trying to give them vitamin D, you're not going to fix the severity of COVID, with giving someone a vitamin D3 supplement after they go into the hospital for COVID.
Right.
You're not. There's been a couple of studies that's if you give them an active form, so you have vitamin D3, it gets converted into something called 25-hydroxy vitamin D in the liver, and then the liver converts it into the active steroid hormone, which is 125-hydroxy vitamin D. So you can give them something that makes it so their liver doesn't have to do that work, and there's been a couple of studies showing it helps with people that have already had COVID. But again, there's a large actual clinical study that's ongoing right now being done by Dr. Joanne Manson. She's looking at prophylactic vitamin D and, severity, incidence of COVID and all that. And so, but omega-3s also. So Dr. Bill Harris, he just published a pilot study on the omega-3 index and COVID death. And of course, this was a small pilot study. It was 100 people. And, people with the highest omega-3 index, again, it was in that 7% range. And this was not statistically significant. It was because there was a small sample size, but there was a 75% reduction in COVID mortality. No telling. I wouldn't at all tell anyone, to take omega-3 to prevent COVID or to not die from it, or that would be ridiculous. Vaccines are what are probably the best way to prevent yourself from both getting and having a severe COVID. We could talk about it in a minute if you want. I'd like to. But the omega-3 thing is really interesting because there was an in silico study that showed DHA, one of the main marine omega-3 fatty acids, keeps the spike protein. So there's a receptor binding domain on the spike protein. And that receptor binding domain swings around. It goes from open to closed. And there's a few of them on a spike protein, 3 or something. And when they're closed like this, they can't bind to the ACE2 receptor. So you can't even latch on. And there was an interesting study showing that DHA was able to keep it in the closed conformation. So this was in silico. Again, grain of salt because it's in silico. You can't say anything. But I was oh, that's interesting. There might, again, for me, I'm an omega-3 enthusiast in a way. I do think there's a huge effect on resolving inflammation, not just decreasing it, but after your immune system's been activated, there's the protectins, the resolvins, the specialized pro-resolving mediators, the SPMs. These things are resolving the inflammation so that your immune system doesn't go crazy and become in this hyper-inflammatory mode. I think this potentially could be how it's affecting longevity. I think that inflammation is a major source of driving the aging process. And there's been studies that have looked at, for example, people that are centenarians, so they live to be 100, people that are elderly, so like 80s, people that are semi-super centenarians are like 105, and then the super centenarians, 110. And they've looked at a variety of biomarkers, telomere length, immunosenescence, glucose, HbA1c, cholesterol, blah, blah, like the whole thing, right? Tons of them. And the only thing that could predict a person going to each stage to living to be either then a centenarian and then later a semi-super centenarian and then later a super centenarian was decreasing inflammation. Like none of the other things predicted each, going to the next stage. So that, to me, is very interesting as well. That the inflammation was like a huge predictor of not only like living the longest, but also cognitive function as well. It was like the biggest predictor of cognitive function. So, again, it's like the omega-3s to me, I'm convinced that the data is not quite there yet to actually solidly demonstrate that like high levels of omega, like we're talking above 7% omega-3 index. And I don't know exactly what it takes to get there. Like I said, I have a 11.7 and I take 4 grams of fish oil a day and I eat sardines and I, eat salmon. So, it's kind of, I'm like the Japanese cohort.
Mm-hmm.
So I don't know what it takes to get above 7, but I think that some of the work coming out of Bill Harris's lab is, pretty interesting, and I think laying the foundation for maybe omega-3 is like a therapeutic type of dose. Maybe there's, again, I'm taking an experimental dose. Like what I'm doing is experimental. Like that's not like this isn't something.
Is there any perceived downsides to such high doses?
So I asked Dr. Harris about that. He flew out for a podcast like last week, and this guy, by the way, he started the whole omega-3 thing like back in like the he started studying it after the whole, the Icelandic Greenland Inuits and their like lower cardiovascular disease. And so this like he was like pioneering on the effects of omega-3, particularly in heart health. But so he's been studying it for decades. And so I asked him like, is there like, what's the negative effects? Like he was giving people 25 grams of omega-3 back in the 80s.
Whoa.
And like doing like metabolic ward
they must have
studies.
Smelled like fish.
Yeah, he said they were giving 3 salmon steaks and a big like, I forgot how much, but like a total 25 grams, but salmon oil, pure salmon oil. He was 25 grams total. Like they were just getting massive doses. So you'd think if anyone knows about negative effects with high dose, it would be him. And he thinks that, so in that particular study, there was one patient, like one participant that had a bleed, like the bleeding thing, where it was like maybe
1 out of.
Oh, I don't remember. Like the podcast is coming out in a couple of weeks. Like,
okay.
If you want to listen to it, but I don't remember. But
Small study,
exactly. But he's gone on, since then. So part of the concern, and we talked all about this bleeding thing, and he really doesn't think it's that big of a concern, to be honest. And he, talked about how, in Japan, like they're basically like they have less than like where their omega-3 index is high. They're not like bleeding as much during surgery or some stuff. I don't know. He was giving some evidence of that, but it does. The omega-3s do affect your leukotrienes and prostaglandins and things that do affect, like platelet aggregation and stuff. But like, I don't like. Maybe it could be bad if you have some kind of disorder, or you're taking some kind of crazy blood thinning medication. He argues that's really not even that much of a concern. But the other concern is that people that already have a cardiovascular problem, there's been a small increase in arrhythmias in some of these people, and it's not known why. And in fact, if you look at, for example, AFib, the end result of AFib that's bad is stroke, and omega-3s have been shown to reduce stroke incidence. So it's like, well, if it was like really causing AFib or doing something bad, then like you should see an increased stroke incidence or like no effect. But no, it decreases stroke incidence. But it's not fun having AFib. Like, right. So I don't, and again, this is super like preliminary. It's not really known. It's like we got to like repeat that. But so, it could be that taking very, very high doses. In the studies that was found, they were taking 4 grams of pure EPA. So it could be maybe there's something to super high doses we don't know about. But I don't know.
Especially over prolonged periods of time, maybe.
And these were people with heart conditions as well.
Right.
And yeah, so this was like, these studies were 5 years.
It is just so fascinating to me that as long as people have been studying nutrition, and as long as people have been studying the human body, that there's still so much speculation as to what you should take and when you should take it and how much. And people like you who study it constantly are still learning new things all the time. Like almost every time you come in here, you're like, okay, so there's a new study. And then, you're telling me about this and you're telling me about that. And it's really kind of wild when you think about the average person that I would venture to say, I don't know what percentage of the average population even takes vitamins. What would you estimate?
Oh, there was a study back in 2015 that looked at this. It was, I forgot. I forgot exactly what the percentage was. It wasn't very high. And the percentage of people that did actually take supplements were the least likely to have vitamin and mineral deficiencies.
Yes, I'm sure.
Big
surprise. My friend's doctor literally told him the other day that you don't need to take vitamins. Just eat a balanced diet and you're fine. Vitamins are nonsense. And I go, you need a better doctor because that doctor doesn't know jack shit. That is such a crazy thing to say when there is so much data on the actual tangible benefits of vitamin supplementation. There's so much evidence. There's so much work being done on it. And for a guy who I know is an orthopedic surgeon, that probably how much time do they spend on nutrition in medical school? And the guy's in his 60s, so it was probably, he was doing this shit in the 80s. Like, what the fuck does he know? And why is he saying this? This is such a crazy, irresponsible thing to say to a person. Well, my doctor said, and I'm looking at this guy, I'm like, get a better doctor.
Right.
Or get a doctor that concentrates on that and go to him when you're dealing with ankle surgery or something. But don't go to him. He's a technician. He's not a nutrition scientist. It's just like they're completely different fields of study, and they're so comprehensive. That's what's crazy about it. Like every time I talk to you, you don't even have any notes in front of you and just rattling off this shit, and it's constant and it never ends. There's constantly new studies, there's constantly new benefits that are unearthed. It's so hard to keep abreast of all this stuff.
Absolutely. And not to mention the fact that doing clinical trials in nutrition. So a lot of physicians, they're used to the gold standard, the randomized placebo-controlled trial. And it is a gold standard. It's the best thing you can do to see if a treatment is working, right? Or if X comes out of, or if Y comes out of X or whichever way it is. But, the problem with nutrition is that everyone has some level of this nutrient X in their body from their diet. And so you get these studies that people, there's no quantification of anything. There's questionnaires like, how much did you eat? How much vegetables do you eat per week? And it's like, oh, I eat, X amount. And then it's like, you actually measure something like a biomarker, beta carotene or, something. And you realize, oh, they eat a lot more vegetables than they thought, or they eat a lot less because it's a biomarker, right? Mm-hmm. So you have these questionnaires, or where the clinical studies are being done poorly, and so not only is it hard to keep up with the data, you have crappy data with salacious headlines like, "Oh, vitamins do nothing," but the reality is the study is like, okay, we never measured anything. We didn't measure vitamin D, which you can make from the sun, and everyone has different levels at the start of the study. And we gave them a supplement where it's 400 IUs, where it doesn't even raise your blood levels, anything. And then we looked at this endpoint, X, like cancer incidence. We didn't measure anything after. And it's like, right. That's a terrible study, but makes the headlines. And, there are some healthcare practitioners that read those, and then they get this idea that, well, they do nothing because I read that study they did,
Yeah.
And in some cases, they're randomized placebo-controlled studies where they are giving a placebo and they are randomizing it and they're doing all that, but they're not measuring the blood levels. They're not measuring anything. So, there's all sorts of problems with that. And I think it's hard to do. It's hard to solve. Clinical trials in nutrition need to be designed better. They do. Like, you need to quantify everything. You need to quantify these nutrients. Like drugs, people don't have that to start with. You don't have to quantify anything. You just give them the pill. Yeah, it's going to raise their levels because they don't have any of it, you know?
But it also just seems like just staying on top of all the research is so time consuming.
Totally. Yeah, absolutely. I mean, there's no doubt. I can't even stay on top of it. And now that I'm a mother, it's even more difficult, you know. But, you know, there's all my notes, and I have flashcards too. But, I mean, I was preparing to come on here, and you know, there's certain things that there's numbers and things like that. If you can know that amount, it helps, you know. So
there's just so much data. There's so much information, and then if you think about like to have your immune system in check, to have your body functioning in check, to have your muscle repairing correctly, to have all these factors, and to have all your nutrient levels balanced and adjusted accordingly, and to make sure that you're getting all your needs as far as your essential fatty acids and your vitamins and your nutrients and your minerals and all these different things. It's so complex. There's so much going on, and so few people are on top of it.
And we don't even know what the optimal levels of these things are, to be honest. Like, we don't even, like, you know, maybe having a diverse diet where you can get a variety of, you know, micronutrients, you're getting these things from your diet, but like then on top of that, maybe there's benefits. Like, we don't even know, right? I mean, so it's kind of a arrogant thing to say, oh, you don't need to take a vitamin because all you got to do is eat a you know, balanced diet. Like, that's pretty arrogant in my opinion, but
in mine as well. It's just, I know how little most people know about it. I know so little about it, and I try to pay attention to as much as possible. And when I talk to someone like you, I'm aware of how little I really know. And it's so complex, and it's so changing and evolving, and there's always new information that's being released.
Yeah, and I'm also aware of how little I know every time something new comes out. Or like there's a question, and I'm like diving into it. I'm like, oh, I didn't know any of this. So, you know, there's always information coming out. So
just overall health is so important, and yet there's so little consideration given to it by most people. And it's one of the most confusing things about human beings. Like, when people are sick, the thing that they want more than anything is to be healthy. They're like, oh my God, I wish I was healthy. But then once they get healthy, they go back to the same eating habits, the same just, you know, just sedentary lifestyle, drinking, alcohol, cigarettes, all the same shit that got them in the mess in the first place. And they don't change much about their nutrition. They don't change much about their exercise habits, when it has such a massive effect on the quality of your life, the longevity of your ability to exercise. Like, I'm 54 now, and I really haven't lost any ability to exercise rigorously, to do it the same way. And I've done a lot of like weird, like one of the things that I did is I completed that Israeli protocol for hyperbaric chambers, where you did 90 days. I did 60 sessions of 90 minutes over 90 days. It's supposed to lengthen your telomeres. That's appropriate to or approximate to a 20-year decrease in your biological age. I did that. I just did it.
Wow.
Just finished it. And I feel great. I don't know what it did. I mean, I didn't really measure my telomeres, and I probably should now. But there's definitely something that happens when you do something like that. But who the fuck has time for that? Like, who's going to do that? How many people are going to be committed to, like, going to some stupid place and lying in a metal chamber for 90 days?
You're an outlier, that's for sure. Yeah. I think there's some, you know, thoughts that it, like, helps increase, you know, blood vessels and growth. And, I mean, like, there's all sorts of things going on. And I know there's probably studies that actually have proposed mechanisms. I just don't know about them.
I'm definitely an outlier in like what I practice, and that I'm dedicated to it. But it's also because I don't like being sick. I haven't been sick in 11 years. Plus, it's been at least 11 years. But I just because of actions, because of things I do. And I just don't understand people that don't want to be healthier. And I really wish it was more accessible. I really wish it was much more common to get comprehensive blood work, and much more common to get nutritional counseling, and much more common for people to be rigorously exercising, to do it on a regular basis, and to realize that when your body's more resilient, when your body's fit, when your cardiovascular shape is higher, you're just better off. You're better off. You can think better. You're healthier. You recover from things better. Like, everything works better.
Right. And now, I think now more than ever, like, being healthy is even more important. You know, like getting to a healthy weight, like trying to like not have these comorbidities like high blood pressure and type 2 diabetes, and you know, like these things there's a huge lifestyle factor involved in obesity, type 2 diabetes, high blood pressure. Like there's definitely things that can be done, you know, that help with that, you know, that help when we were talking about sauna and exercise. And you know, there's even like, you know, other ketogenic diet does help with like weight loss, but there's other strategies for that as well. And having the vitamin D, having enough vitamin D and omega-3s, like, you know, to me, it seems like, yeah, it should be beneficial. Everyone should they should be like super motivated, you know, to do that. But it's always hard to get people to do it. As you mentioned, it's like extremely difficult. So even with my mom, and I constantly am bombarding her with information.
Isn't it strange, though, that humans are so reluctant to do things that would benefit them? It's so weird.
I don't think they believe it, or they might just, you know, it's too much
hard.
work. It's too much work, and what little benefit, you know, is it worth it? Like, I think that's the kind of stuff, like, there's lots of excuses.
Right.
But, you know.
But long-term, clearly, there's a lot of benefit. Just you have to put it, it's like you're building a mountain with a layer of paint at a time.
Right. Yeah. You have to put in the effort. I mean, for sure. And I do think even with, you know, COVID-19, there's obviously data showing that, you know, people that are obese or have a comorbidity, they're more likely to have a severe form of it. And it's like twice as much in some cases, you know, it's not like, you know, something like a vaccine would do, but it's definitely plays a role. And, you know, it should be a motivating factor. But, you know, since we're on this topic, can we talk a little bit about vaccines? Because it's something I have seen a lot of misinformation, like on everywhere, Facebook, on, you know, different news media outlets, and I think there's really like some main ones that I just feel are causing harm. And so there's really 8 of them. We don't need to talk about all of them, but I think the 8 really are that, you know, SARS-CoV-2 is not that bad. COVID-19 is not that bad. And, you know, vaccines basically don't prevent transmission. Spike protein from vaccines are cytotoxic, therefore they're really bad. That vaccines are going to cause something called antibody-dependent enhancement, which is going to make you have a more severe disease. There's the vaccines are going to cause infertility. There's the vaccines are going to cause a more virulent strain or variant. And then there's one more that, alternatives to vaccines exist right now that are just as good. And I think that there's a few of those that are really, I mean, just like blatantly, they're wrong. All of them, I think, but I mean, you know, there's some that are more important than others. And I think that I would like to talk about them. You know, I think first and foremost, there's like 2 groups of people, mostly. One thinks COVID-19 is bad, doesn't want it, wants the vaccine, and the other one that thinks it's not that bad and that the vaccines may be harmful. And there's also
Do you think the vaccines are harmful to anyone?
Well, of course. I mean,
do you know anyone that's had bad reactions to vaccines?
I personally, interestingly, I know a lot of people that have gotten vaccinated, and the only person that I know that had something was like, she had a headache for like a week and a half, and then it went away. Oh no, another person I knew had like nausea for like a couple of weeks. They were like nauseous more frequently, but it went away. You know,
do you think you would feel differently if you knew someone that had had a stroke, or someone who's had heart attacks, perhaps young people that have?
Well, it's hard to say. So, you know, people react differently, obviously. When you're giving, you know, more than 169 million people are vaccinated, right? I mean, that's half our adult population is vaccinated, fully vaccinated with COVID-19. And it's not zero risk. Some people are going to have an adverse reaction. And they do. It's a big world out there. Like if you were to give 169 million people a peanut or a shellfish, like some people are going to have very adverse reactions. Some people are going to die. Like it's a big world. But, with the stroke or the heart attack, you have to like, so if you're trying to compare, for example, let's say, you're looking at actual COVID-19 deaths and from heart attacks and strokes, and you're looking at the vaccine adverse events reporting site VAERS, right? And that as well. You have to realize that basically in the United States, like in 2017, there was a publication in the Journal of Circulation. Someone dies from cardiovascular disease every 30 seconds in the United States, like every 30 seconds. Most of those people are above the age of 50, and certainly most are above 65. But every 30 seconds, someone's dying from cardiovascular disease. Every 40 seconds, someone in the United States has a stroke. Every 4 minutes, they die from a stroke.
But this is also very, very rare in young people, particularly young, healthy people. But one thing that has occurred in young, healthy people that have been vaccinated is myocarditis. And some people have had blood clots, like quite a few blood clots. And there's speculation, right? The Salk Institute released that paper about the spike protein causing some sort of deterioration of the blood vessels. Did you read that?
I looked at the spike. I've been looking at a lot of the spike protein, and
that's from COVID-19. They're discussing it.
They're talking about from
the actual disease itself.
Yes. So, first of all, like you have to like you're either going to get infected with SARS-CoV-2. Most people are going to be eventually. We're all going to be exposed to it. So you're either going to be vaccinated when you're exposed to it or not. And people are dying from heart attacks and blood clots, and even people are getting myocarditis like 100-fold times more than vaccines. Like the myocarditis link from the mRNA, specifically the mRNA vaccines, is real. And I think the last I saw it was like 50 per million, which it's still rare. And it's
happened to two people that I know.
Up until then, and actually now that you asked me, I forgot. I had someone who's a supporter. I talked about vaccines in one of my Q&As I do, and they went and got it, and they were younger and ended up having some kind of myocarditis. So I do know someone that had I don't know them, but they emailed me.
Now, what happens if you have that? And like, how do you recover from that?
But you realize it's happening to young people. So myocarditis is caused by two things. One, by inflammation. Two, by direct viral infection. And it's more common in adolescents and young people.
And it's an enlargement of the heart?
It's inflammation of the heart. It can lead to that, yeah. But it's happening in young athletes with COVID-19, and it's happening like more frequently than people that are getting vaccinated. So it's still like, well, if the person that got vaccinated, look, it is a risk, but it's still pretty rare, and it also is treatable. In most cases, they treat it like within a few days, and it's isolated.
Why do you think that people, there are people that are completely asymptomatic when they get COVID, or if they do get it, it's very mild? Do you think that's because they have a lower viral load that they've been infected with? Or do you think it's their immune system that fights it off? Like, what do you think is happening?
It could be any and all of those things, a combination of them. And, but so even if you think, if you're looking at just the most extreme part of the deaths, right? You've got over 624,000 deaths in COVID-19. Most of those deaths are happening in people over the age of 50. And if you look at
most of them have 4+ comorbidity factors, right? Isn't that the average?
I don't know if it's 4+ for average for. I think the comorbidities increase. Yeah, I think
let's find out what the number of comorbidities are in terms of the deaths. It used to be 2.6, but I think they raised it to 4.
Really, the number of them are 4. Okay,
I think so. So I might be wrong, but I know it was at least 2.6.
Right. So then there's the argument. Well, I'm healthy. I don't have comorbidities, right? I mean, so what should I do? Should I get vaccinated or should I be exposed to the virus? And I think there's a lot of evidence, and there's multiple lines of evidence. One, there are people with mild symptoms that are getting post-acute COVID syndrome. They're getting this, what people call long haul COVID. And the majority of people...
What do you think that is? What is long haul COVID?
I don't know what it is. I think it depends on the symptoms. I think there could be a variety of causes for it. So there are people, and most of this is happening in teenagers to like 50. Most of the people that are older are not getting this long haul COVID. It's like happening in people that are mostly not being hospitalized. People that don't get hospitalized originally, like they have mostly like pretty mild symptoms, in some cases even asymptomatic.
Mm-hmm.
There was a study published in the Lancet like last year showing there was a 7-fold increase in stroke incidence in people under 50 in the United States compared to the year before that, before the pandemic started.
And that is probably because of the spike protein that causes this deterioration of the blood vessels and blood clots. Is that what it is from the virus?
Well, I don't know what it is. I mean, there's lots of things. Viral infections themselves can cause hypercoagulation. They can cause blood clots, that's like known from other viruses. Like there's inflammation
without
the spike protein. So I feel like I haven't got to address everything, but let's talk about the spike protein
real quick. I think this 4 point is that where I would find this information. I hope that's the spot.
Yeah, there was an average of 4.0 additional conditions or causes of death for data on deaths involving COVID-19 by time period, jurisdiction, and other health conditions.
For death.
This is only 5%. The COVID was the only cause, and then
for only 5% of the COVID deaths, COVID-19 was the only cause mentioned. So out of those 600,000 people that died, only 5% died just from COVID-19.
Well, I mean, so you have people that are COVID-19 is going to make their comorbidities worse, and that could be the same for a vaccine. It could be the same for anything, right? I mean, so like something that's going to activate the immune system.
Yeah, but the concern is with vaccines, the negative effects that what people are worried about, I think, is young people that are healthy that have negative effects, like that have had strokes or that have had thrombosis or myocarditis and those issues, right?
Well, again, if you look at the data, young people are also experiencing those things at a higher rate. And are those all the people with the comorbidities? Like, I don't know, I'm not sure, but it seems as though no matter which way you look at it, like it is worse to be exposed to that virus. And like, how do you know that person that had that myocarditis wouldn't have had it X-fold worse with the COVID-19? Because it's been shown to happen in young, healthy athletes. And people
Has it been shown in large numbers? Like the athletes?
More so. It's
more so than the vaccine? Is that what you're saying?
Yes, I'm saying that it's happening. Myocarditis from the vaccines is happening in younger people at a higher rate than from the vaccines.
Do we have accurate data, do you think, about how many myocarditis instances we have from the vaccine?
Well, you could argue there's an underreporting. I think so anyone can submit data to the VAERS, and I think when it comes to someone who's younger, they're more likely. I mean, so healthcare professionals have to submit to the VAERS if there's like something that's life-threatening, which myocarditis could be, or if it's a death or something that's like changes their daily functions, like congenital effects.
They have to submit it.
Yes, they are. If they are,
But how do they know that myocarditis is caused by the vaccine?
They don't. But if the person had gotten vaccinated, and by the way, there's no time constraint. Like it's not like, if they've only been vaccinated within like 2 months, like they're supposed to submit to VAERS. Like if someone was vaccinated and then something, yes.
Is there encouragement or discouragement to submit to VAERS?
I don't know. But I mean, if you again, even just looking at the deaths in every age group, even. Like, people that are in my age group, 40 to 49, there's 20,000 deaths that have been linked to the confirmed COVID-19 cases.
Right.
Whereas, in VAERS, it's 200. And even if you triple that.
For people with comorbidities, obviously, it's a real issue.
Yeah, I don't know if that's always the case, but yes, definitely with people with comorbidities.
Because according to this, what we pulled up, it's 5% that are dying just of the COVID. 95% have an average of 4 comorbidities.
Okay, well, if that's true for all ages, then, yes, people with comorbidities are more likely to die. But also younger people, like I said, they're more likely to get, these long haul symptoms where I've known so many people, that they've gotten like their loss of smell or taste has been like several months. And there's now studies showing that, there was a huge study out of the Biobank, UK Biobank data, where right before the pandemic started, MRIs were done, brain scans on like almost 1,000 people. It was like over 800. And then the pandemic hit. People got COVID, some people didn't, whatever. So they brought the same cohort of people back in for a brain scan. And, basically they corrected for people. So they compared people that were the same age, same gender, same sex. And then they also time between scans. And they found that both mild and severe COVID-19 cases caused a atrophy in the gray matter region of the brain. It was worse in people that had it more severe.
Right.
Understandable. But people that had mild cases that didn't go to the hospital had it.
How many people did they study with this?
It was over 800. Yeah. I mean, it's you need more data to confirm, but I mean,
were these people, did they stratify it by age? Did they have
age,
it by
gender,
health?
ethnicity, health? I don't know.
Did they have comorbidities? Did they factor that in?
They had people that age the same age, as people didn't get COVID.
Right.
They didn't have it. I mean,
And
this is several months. This is just months
Right.
after. I don't know about the health.
Did they monitor their nutrition or find out what kind of supplements they were on?
I don't know.
Not?
I don't know if any of that data was in it. But
do you think that data would be a factor at all?
I don't know, because I know people that supplement, that exercise, that have had were diagnosed with. They had a mild case and they were diagnosed with POTS. Postural orthostatic tachycardia syndrome, where their heart was racing, like tachycardia was racing, just uncontrollably. They were dizzy, had no energy. I mean, this was months, and they finally got diagnosed. And it's like a lot of people coming out with this, but
Do you know anybody that had COVID and got through it with almost no symptoms at all and was very mild?
Well, yeah, no symptoms at all. But the people that I do know, most of them had some kind of weird taste issue, or smell thing for weeks and weeks. But
You don't know anybody that didn't have that?
I don't, because most of the people I know that had it lost their smell. I know people are out there that don't have any symptoms at all,
I think it was something like 40% were completely asymptomatic, right?
Well, there was a study in Israel, kind of going back to the stroke thing, that found, this was published in April. What was it? Maybe April 2020 or something, or maybe July. I don't know. It was still 2020, but they looked at patients that were coming in for stroke, and these were younger than 50, and 30% of them had COVID, didn't know it because they were asymptomatic and they were younger people. So it's like you'd think, well, if they had four comorbidities and they had COVID, they'd know it, right? I mean, so they were coming in for stroke, and they had no idea they had COVID until they were tested, and they found out
they had a stroke.
Exactly.
Interesting.
So getting back to so there's reasons that I personally think that people that are younger and healthy should get vaccinated, and for one is because for most people, the vaccines are safe. And I mean, we just have data to show that. We have hundreds of millions of people that have had the vaccines we're getting in the United States that have been vaccinated worldwide. The second, it's just hundreds of millions of people. But also the fact that, some of this stuff where you're talking about spike protein and you're worried about spike protein, this is important because the spike protein from the SARS-CoV-2 virus is a different spike protein than what's in the vaccine. So when the vaccines were made, these are ones in the U.S. So this is both mRNA vaccines, the Pfizer-BioNTech, and then the Moderna, as well as Johnson & Johnson. The protein itself is locked in a conformation. It's called prefusion, which is kind of closed together. And typically what happens when viruses interact with our cell membrane, they elongate. It's called postfusion, a postfusion viral complex, and changes structure. And so the actual, both the mRNA vaccines and Johnson & Johnson locked the spike protein in the prefusion conformation. They inserted 2 proline amino acids and kept it locked. It's a different protein. It's a different structure. It can't open up. We don't know, there's no evidence that these studies that have the one that you're talking about, the Salk Institute. The other ones that they have injected spike protein from the SARS-CoV-2 virus into tracheas of hamsters and also mice. There's been some in vitro studies showing the spike protein is harmful in those studies, and it's binding to the ACE2 receptor. And once it binds, it can undergo like fusion and endocytosis, but we don't know if the spike protein from these mRNA vaccines are doing that. Like, if you're going to make that claim, it's a different spike protein. You can't make that claim with no evidence.
So what do you think is happening to the people that are getting myocarditis or strokes or thrombosis or blood clots
Well,
from the vaccine?
So here's the thing. I think the other part of that is that people are concerned that the mRNA vaccines don't stay in the deltoid tissue.
Right.
And they're somehow getting into circulation and causing havoc, Here's the thing. Like, so these mRNA vaccines, they're basically encased in this lipid nanoparticle, and there's some other things in there with it. But generally speaking, when they're injected into the muscle tissue, the lipid nanoparticle has a half-life of a few hours, long enough to protect the mRNA from degrading. The mRNA, again, the half-life is, anywhere between some 72 hours or maybe like a little longer. And the spike protein itself that's made in your cells peaks after 24 hours, and then it goes away after 48. The concern from people that the spike protein from the mRNA vaccines, or even just the whole mRNA vaccine itself, the whole lipid nanoparticle with the mRNAs, like going to other tissues, comes from studies that were done from Pfizer. And it was kind of leaked out, and these studies were called biodistribution studies. And they did rats and they did mice. In the rats, they injected 50 micrograms of the Pfizer-BioNTech vaccine. So humans, we get 30 micrograms per injection. They gave the rat 50. So, how big is a rat? They're getting almost twice as much as a big human's getting. If you look at the rat equivalent dose, 50 micrograms is 10 times the rat equivalent dose. They were doing that intentionally for safety and to see what happens when you give 10 times, like a high dose. And what was found is that you could see they radio-labeled the lipid nanoparticle. And you could see some radio-labeled parts in other organs. Like, you'd see it in the spleen, in the liver, in the bone marrow, a little bit of other organs. But again, this is 10 times the dose. And this was a radio-labeled lipid nanoparticle. And typically, when you inject something into like your muscle, you've got lymphatic system, lymph is like surrounding it. Lots of immune cells are there. And so what ends up happening is you have like dendritic cells immediately when something foreign, like this lipid nanoparticle, they chew it up into pieces. And through phagocytosis, it's like, it gets taken to, liver and stuff for like metabolic purposes, right? So we don't even know what that was, not to mention the fact that it was, 10 times the dose. How is it going to get into the circulation? That's weird. There have been some earlier studies on mRNA vaccines that have shown when you directly inject it, like if you do it like intravenously, it goes to the liver. The mRNA vaccine goes to the liver, and your liver tries to get rid of it. The same biodistribution study also injected mRNA vaccines from Pfizer-BioNTech into mice. But this time they did the animal equivalent dose, which was 2 micrograms. And there was a little bit found in the liver 24 hours later, but it was gone by 48, nothing. And there was no other organs that they showed. I mean, presumably if it was showing up in other organs, they would show that, but like in the animal study. So that's one piece of evidence. The other one I've seen going around is like there was a small study, 13 people, and they were looking at the antibody response to vaccines. And within these 13 people, they used a test called the Simoa, S-I-M-O-A, to measure spike protein and the S1 subunit of the spike protein. And they found that 3 out of 13 people they could detect spike protein, and 11 out of 13 they could detect some of the S1 subunit. But it turns out like this test, the Simoa, is really good for looking at like IgG, antibodies. But when it comes to actual spike protein, it's 25% false positivity rate. So another study showed this, that you could take people pre-pandemic, run this test on them, and they'd show like they had spike protein. 25%
So it's
of
just
the
a
time.
bad test?
It's an inaccurate test for spike protein, or definitely for spike protein, but in also for the S1 subunit. So I don't think you can make a claim that because you have 11 out of 13 people showing this using this test. That's the only study that's shown that. Like that to me is like you can't make any claim from that. It's
Right.
like there's no way.
So what do you think is happening to people that are having bad responses to the vaccine? Like when young people are having myocarditis or heart failure, when they're having strokes, like what do you think is happening?
Well, it depends also on the vaccine itself. So what we know about the mRNA vaccines is that they are the ones that are associated with myocarditis.
But
right?
isn't the Johnson & Johnson's also associated with blood clots?
That's different, right? I'm saying myocarditis.
Oh, okay,
so,
just myocarditis.
Yeah. So these are mRNA vaccines, and they do elicit a pretty strong immune response, and that's why they've been so effective. I guess I should say the efficacy, if you're looking at clinical trials, in terms of preventing SARS-CoV-2 infection, compared to Johnson & Johnson initially, but Johnson & Johnson uses an adenoviral vaccine. So this is the first time adenoviral vaccines have been used, widespread. Like they've been used in clinical studies dating back to like the 90s or 80s or something like that. But I was looking at some of those research studies, and there seems to be a link between blood clots, thrombosis, and the adenoviral vectors back in those studies. And I don't think they're understanding. It's still kind of rare. I mean, it's still rare. And again, COVID is causing blood clots in people, even people that are healthy, like people that are, getting a stroke. So, I don't know what it is, but it's still pretty rare with the adenoviral vaccines and the like thrombocytopenia and like, things like that. The myocarditis, again, still pretty rare. And that's with the mRNA vaccines. It's inflammation is playing a role in that, and why that is, I don't know. Younger people, children and adolescents, are more prone to myocarditis from viral infections. Probably has something to do with their immune system being so much better, and when you activate it, maybe sometimes in some people, there's too much of it going on. I don't know. I don't think this is linked. I don't think that you're going to find, the spike protein from the mRNA vaccines are like floating around in your vascular system and like going to your heart and like
is that
binding
possible
on,
at all?
Well, I mean, in theory, yeah, it is. But, again, like the spike proteins from the mRNA vaccines are different from SARS-CoV-2. We talked about that pre-fusion, right?
Do we know if those spike proteins that are different, do they have the same effect on the body, or is it a minimal effect? Like what is...
Well, we know that this work was done by Jason McClellan. He's actually in Austin. He's at the University of Austin. He's the one that basically did this 2-point mutation and kept the spike protein in the pre-fusion complex. And this was work that he had done previously with RSV, respiratory syncytial virus. This is what every kid gets, right? And if you want to hear about a vaccine tragedy story, like that's the poster child. These studies, there were clinical studies done back in the 1960s on RSV vaccines, and I don't remember the number of people in the actual study of infants and toddlers, but 80% of the infants and toddlers that got the vaccine and then were naturally exposed to the virus got hospitalized, and a couple died. Versus 5% of the infants that did not get the vaccine and were exposed. So the vaccine, we know now from what was happening in that sense was that the vaccine was causing something called antibody-dependent enhancement. And what that is, there's two ways that it can happen, but one of the things, and it's induced by vaccines, one of the things that can happen is it can make viruses come into your cells like better. So you like more viral particles, you get infected. And the other way is, and this is what was happening with RSV, is it basically causes your immune system to become like more dangerous and active, and be more harmful after you're exposed to the virus where the vaccine is supposed to be protecting you from. And for a long time, and I think Jason was involved in figuring this out, Dr. McClellan, that it's the post-fusion antibodies that you make from a vaccine that can cause that, because the post-fusion, remember there's two different conformations of a lot of times these viral proteins do that, including the spike. The post-fusion ones are not as good at actually protecting you from the actual virus, but they kind of in some cases can even mask it or become harmful. Anyways, they know now that the post-fusion antibodies play a big role in antibody-dependent enhancement. And those are not antibodies that are being made in all the vaccines in the United States. AstraZeneca didn't do this, 2-proline point mutation change, but the vaccines that we're using in the United States are. And so the antibody-dependent enhancement theory that's going to happen, that people that are vaccinated, they're all going to be really sick. They're going to be sicker than people that just get the virus.
I haven't heard that.
Yeah, it's like a big one. That misinformation. It's misinformation that's so for one, you'd be seeing the hospitals fill up with vaccine people and not unvaccinated, which is what we see.
But in Israel, they are filling up with vaccinated people.
Well, in Israel, it's mostly not vaccinated people that are filling the hospitals.
I don't think that's true right now. I think I was reading something today about that the majority of the people that are hospitalized in Israel were vaccinated. And they're attributing that to the higher rate of vaccinations in Israel, and that the idea that these vaccines have a waning life of effectiveness, so that after 6 to 7 months or however many months it is, that they're not as effective, and then you're seeing people get sicker.
Yeah, and that's been shown in Israel. Israel showed this. They had a breakthrough study that was published in New England Journal of Medicine. They showed that basically you could take healthcare workers that were vaccinated and measure their neutralizing antibody levels a week before they became infected, or you'd look at their antibody levels a week before they came down with a breakthrough infection. And it predicted the breakthrough infection. In other words, people with lower neutralizing antibodies were more likely to get this breakthrough infection. And then another study was published by Miles Davenport Group, and it was published in Nature Medicine, where he did some kind of modeling and found you had to have 6 times more neutralizing antibodies to protect from actually getting infection than from being hospitalized as well. So, and the Pfizer vaccine, so there was a huge study that came out of the Mayo Clinic, and this was recent. It was multi-states, 25,000 people, and there were 25,000 people that were vaccinated, and they looked at and 25,000 people that were unvaccinated, and it was looking at effectivity of the vaccine. So in other words, protecting you from actually getting the infection, and then protecting from severity, so hospitalizations. And so this is with the Delta variant, because everything's changed now with Delta variant, right? I mean, these vaccines were much more effective at preventing infections with the Alpha variant being dominant, which was the dominant one.
How do they
July.
know when you get infected if you have a Delta variant? Because the friends that I've had that have gotten sick with COVID, particularly ones that are already been vaccinated that got sick afterwards, they didn't test for what variant. They just tested whether or not they're positive.
Yeah, I mean, some places aren't doing that, but you'd have to do a
all
PCR
of
test.
All of my friends that tested positive after they've been vaccinated.
Yeah, I think now, because the Delta variant is so much more transmissible, it's taken over. I mean,
they
it's
just assume that it's a Delta variant.
Exactly. They just assume because it's pretty much taken over. But with that study, they showed the Pfizer vaccine went from being 80 to 95% effective at preventing infections to 42%. So, there's a drop in that. And the Moderna vaccine was actually much better. It dropped down to 77% effective.
But the side effects of the Moderna were a little stronger as well, right? Because the Moderna conferred more of the spike protein, and it made your body more resilient to the virus, but it also gave you harsher side effects. Is that the case?
So I don't know if the Moderna, I don't know why that would be, other than that, maybe eliciting a stronger immune response. Moderna vaccine has 3 times the amount of mRNA in it than Pfizer.
3 times.
About 3 times. So, but getting back to that, with the transmission and looking at, overall transmission, even aside from something called onward transmission, there's 2 types of transmission. The vaccines are protecting people from getting this virus because there's still some effectiveness of them. They are. It's reduced, but when you have, it's still 40% of the people that are have the Pfizer X amount of months later, again, neutralizing antibodies probably play a role in that, if you have more, if you're younger. So there's all sorts of studies showing that older people make less neutralizing antibodies with vaccines, and also time. Of course, they wane over time, but there's lots of studies showing the people in the hospitals are older, of course, the ones that are getting the breakthrough infections. And so these vaccines are still preventing overall transmission. They're preventing overall transmission.
Well, if people are getting sick while they're vaccinated, and if the vaccinated people can still spread the virus, how are they preventing?
So there's overall transmission. And
they're
then
reducing? Are you saying they're reducing transmission? They're reducing?
I'm saying it's still, for the overall transmission, yes, it's reducing. It's reducing
so it's not
overall.
preventing.
Sorry, no, it is not preventing. It is reducing overall transmission. There's also onward transmission, and that's where a lot of this new stuff has come with Delta, where there's been some, the CDC put out some data, and then there was a big study out of the UK where they measured peak viral levels in vaccinated people and compared it to unvaccinated. And peak viral levels were the same in terms of, how much virus they were shedding. But the virus basically, it's replicating for a number of days, and you're shedding for a number of days. It's not just peak. And it's not just the first, few days. It continues on. And so a Singapore study looked at that. They looked at, this was, not a huge study, but this was with the Delta variant, and they saw that while the initial levels of virus were the same in both vaccinated and unvaccinated, vaccinated people cleared it quicker. They cleared it faster, so they weren't shedding for as long of a time, which would also suggest that if you were to take a random sampling of the population, not people that are going in and seeking healthcare, in which case people that are going in and seeking healthcare, they're like getting their peak viral infection, right? There's a REACT study. It's a real-time study that's going on in the UK where they get all this data real time. They also found if you take a random sampling of people, vaccinated people have less viral, this is with Delta, they have less viral load than unvaccinated, which is what you expect if vaccinated people are clearing it quicker. So there is even some evidence to suggest that even with Delta variant, vaccinated people are somewhat still even affecting onward transmission as well. In other words, preventing the transmission through just your infectiousness making other people sick.
But if there's these issues that you were talking about with people that even have very mild cases they're developing, these problems with brain matter and all these different issues, these are still happening to people who are vaccinated who get COVID, right?
I don't know. I don't know.
But this was one
data.
of the main reasons why it's a good idea to get vaccinated. Wasn't that what you were saying? That
it's a reason
to prevent infection, but if
it's a reason on the individual level to it's like, okay, well, do you want to be exposed to the virus without being vaccinated, or do you want to be exposed with being vaccinated and maybe not even get it? It's a gamble, right? I mean, like, you're going to be exposed, so like either you're going to be vaccinated and not get it, or you might get it with Delta, and there's no telling.
Or you can be unvaccinated and not get it too.
That's not going to be the case for unless you're a hermit and never, it's eventually going to.
I've been exposed to it many times and I haven't gotten it.
You don't have any antibodies against any?
No, I never got antibodies. I did have a higher level of monocytes. Like, I got tested, my blood tested, and it showed that I had gotten over some sort of a viral infection. I'd beaten it off.
Well, I don't know. It sounds like you're either an outlier or maybe you did have it and it hasn't been detected yet.
Well, there was a couple of days where everybody around me got it, and a couple of days of my workouts felt really shitty, and I just took it real easy, and I continued the same stuff that I always do in terms of my protocol, like with the sauna and all the other stuff that I do, and vitamins and supplementation, and my whole family got it. I never got it.
Well, obviously there's people that are going to get this that are going to have hardly anything and maybe not even know it. I mean, that's happening.
But I got my antibodies tested. I had all those things done. Yeah,
I don't know.
I got tested every day for COVID.
I have no idea. I mean, go for the nucleocapsid protein. Get that tested because that would be more, I think, indicative.
And that is a blood test?
You can get that from Quest, I believe. It's either Quest or LabCorp. I think it's Quest. It's nucleocapsid. But I mean, even aside from that, if you have something that can, you don't want the hospitess to fill, the ICUs to fill up.
Course.
Like, you don't,
No, of course. Now, here's another question. If the effectiveness wanes of the vaccine over 6 months or however much time it is, and you need a booster. Do we have any information or any data as to what the effects of the booster is? If we have the information about the second dose of the mRNA vaccine being more difficult for some people to tolerate, they have more difficult side effects. Do we have any data about what a third shot is going to be like, or possibly a fourth, or ongoing? And is there a point in time where it's going to be detrimental to your health to continue getting booster shots?
I have no idea. I
Is
don't
that
think there's
the
data.
road that we're getting on?
I think, in my opinion, and again, I should have said this earlier, I am not an infectious disease expert.
Right.
I'm not about, this is my opinion. I know you're interested in my opinion.
Yes.
And it is my opinion that elderly people, and maybe those people with the 4 comorbidities or 2 or whatever it is, any comorbidities probably, those people are, what we're seeing in hospitals right now, most of them are people that are immunocompromised or older. And they might benefit because they have a lot to lose if they get COVID. Mm-hmm. They have a lot to lose. They have their life, potentially,
sure.
right?
Yeah.
So there may be an argument for people to get a booster at that age. I'm not sure there's an argument for people like myself to get a booster.
Now, but what
now,
about in
right.
10 months? What about in a year?
Or even in a year. Like at some point, the vaccine, well, I don't know. It depends.
Is there a lot of I don't know going on here with this stuff?
For the boosters?
For all of it?
No, well, for the original data, we've got the original clinical trial with 75,000 people with both mRNA vaccines.
Right, but it lasted for 4 months, right? There
was phase 1, phase 2, phase 3.
Right, but initially the thought was you are never going to get COVID if you've been vaccinated, and you're not going to spread it. I mean, this is what Fauci had constantly espoused. This was the thing that they were saying. Now they've changed it.
Yes, because we have a new variant. I mean,
is it only because of the new variant, or is it because of the waning of the original vaccine's effectiveness?
Maybe both.
Right.
Probably both, to be honest. I do think that there's a lot of evidence to suggest that the neutralizing antibody levels can predict whether or not you get the SARS-CoV-2 infection. In fact, if you look and compare at people that have had natural immunity to people that have just been fully vaccinated, they're pretty equal in terms of as likely to get a breakthrough infection or a reinfection. But if you take a person that has natural immunity and then they get a vaccine, they have something that is referred to as hybrid immunity, and they're like 2.3 times, 3-4 times less likely to get it. Like they're like superhuman in a way, having natural immunity plus the vaccine.
But also people that have had natural infections and then have the vaccine have a much higher likelihood of getting an adverse side effect.
Do they?
Yes.
A
good friend of mine who's an elite athlete got infected with COVID. It was nothing. He breezed through it, and then he got vaccinated, and he was wrecked for 11 days.
I personally don't, and this is probably controversial, but I think, an individual has to decide, and, the CDC is saying people that have had natural immunity should get vaccinated, but I don't see any reason why they have to be honest, unless they are just terrified and don't want to get it, and they're maybe they have that 4 times comorbidity or something like that.
In all fairness, he's the only one that I know that had an adverse side effect that was also vaccinated and had COVID. All the other friends that I've had that were vaccinated after they had COVID had no problems. But he had a bad one. He had like massive fluid buildup in his body.
Again, it's not zero risk. People are having adverse effects, but there's so many hundreds of millions of people that have had it.
Right.
We know about myocarditis from mRNA vaccines. We know about that because of the VAERS data. We know about the blood clotting from the adenoviral vector vaccines, including Johnson & Johnson, and AstraZeneca is not used here, but this is stuff we know about these side effects. They're still rare.
What do you think about prophylactic use of certain medications? Like the big and the most controversial one is Ivermectin, of course. They use it in Argentina with critical care workers, and they used it prophylactically, and they had a very high success rate with using it prophylactically. And there's some real controversy because there's no real studies. There was something that just came out recently out of India and India's use of ivermectin, but it's not there's not something that there's like real rock hard data that you can show that points to the effectiveness of it. But you have like the frontline critical COVID care workers who, like Dr. Pierre Corey, who's promoting the use of ivermectin, and many other people that also have shown they've had good use of it. But it's very controversial, right? Like a lot of people don't even want to prescribe it. A lot of doctors, they don't even want to hear about it.
So I have done a lot of sort of trying to read I don't have the anecdotal evidence that Dr. Pierre Corey has in treating frontline COVID patients. I don't have any of that anecdotal evidence, none of it. So all I can do is look at data, and data that's, either preprint or data that actually has been peer reviewed and published. And what I see, and I mostly see that a lot of people doing this on websites, they're like aggregating all this data and putting it together. But there's like some major problems with the way they're showing the data. That is like, it's a big concern. The one is that, people are using different, obviously, doses, but there are different co-interventions with both the treatment group and the control group. So you have people getting ivermectin, or you have people getting ivermectin and azithromycin, or you have people getting ivermectin and doxycycline, or you have people getting ivermectin, azithromycin, they're getting like anticoagulants in some cases, they're getting vitamin C, they're getting the kitchen sink, okay? Mm-hmm. And then you have the control groups vary considerably. They're getting, maybe in some cases, in the best case, a placebo, or they're getting, the standard of care treatment, or they're getting hydroxychloroquine, or they're getting hydroxychloroquine and azithromycin. Okay, so you have a bunch of different treatments and co-treatments happening with each group. And you have people aggregating all those together and that's just part A. Part B is you have different endpoints being measured. So you have like time till negative real-time PCR. So like basically viral clearance, right? When you get negative. You have people looking at hospitalizations. You have people looking at mortality. You have people looking at, what's another one? Okay, the prophylactic use. Endpoints, and then people just like aggregating stuff together. Oh, there's an improvement, and they're aggregating all these studies together. And then the other problem is that you have, and it's kind of something you alluded to, is that you have small sample sizes. In such case that the incidence of something is going to be so small because the sample population is so small. So I'll give you an example. Like you have 50 people in one group, and you have 64 in another group, and 2 out of the 50 people were hospitalized in the control group, but 0 were hospitalized in the ivermectin group. Like that is such a low incidence of events that you can't be certain. But they take that and aggregate it with all this stuff, and so then it becomes
just a massive lack of studies.
Not only that, and I think this is what's putting people off. You said doctors and stuff. Mm-hmm. There is a huge overstatement. For whatever reason, maybe it's because people have anecdotal, maybe they're treating patients like, I know this works. Maybe they're passionate about it because of that.
Right.
Or maybe there's also people that are pretty much just not wanting, they think the vaccines are harmful, and they want to find something else they can champion. So I think they're doing harm to the ivermectin world by sensationalizing it and making it like this miracle thing.
Right.
Because it is doing harm. And I had a knee-jerk reaction at first. It was like, oh no, I know this is like, you can't say something's 99% effective. Like no clinical trial known to human history has ever shown something 99% effective, right? So that was like a red flag. But, so there's a couple of things here. There's therapeutic treatment with ivermectin, and then there's prophylactic, right? Taking it if you know you've been exposed, in which case I think is a little more reasonable than like, I'm going to take it instead of a vaccine, in which case there is no evidence that ivermectin is going to protect you from getting it like a vaccine or prevent you from being hospitalized as a vaccine. There's certainly, I don't even know if there's any evidence on Delta variant. This is a different variant. This is different. We don't even know. What is ivermectin doing now? Right. We had to change the whole game with vaccines. So that's another issue. But my opinion is that when I look at all the data, I see you'll see again, it's all over the place. They're using this and that, but just forget all that. And, it seems to me like there's huge variation in, things like mortality. which makes sense. I would think something like this would be more effective if you give it earlier on and you're preventing from, a severe like hospitalization or something like that.
I think that's the idea behind it, along with monoclonal antibodies, which also
are now
like
changed.
Regeneron.
Now Regeneron's not even working as well against the Delta. So these
Really?
treatments, yeah. But here's the thing that I noticed that was consistent with ivermectin. It did seem to be, in almost every clinical trial, it seemed to shorten the time to a negative PCR rate. In other words, help clear the virus. Like that was the one thing, the one endpoint. Now, again, some of these were ivermectin plus blah, 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 blah. Okay, but aside from that, that was the one consistent thing I saw. And I was like, oh, instead of seeing, like 0 studies showing that and 3 that or this, like it was the one thing I was like, wow, everything's really pointing to possibility of it clearing the virus faster, which could affect transmission.
But there's really just a lack of studies. Really a lack of
and
solid
a problem
studies.
of just
Everything
like
piling
it all on and making these
Right.
large these grandiose statements and to be honest, the prophylactic data, like there was one study that got me excited. It was in like 600 healthcare workers
in Argentina.
No, this was the one in Egypt.
Oh, okay.
And that one got withdrawn because it was like there was like falsification of data. They're like enrolling patients, but like patients had died and they were enrolling them like after they had died. It's like, okay, that was not right. So
Yeah.
I do think, it is my opinion that like I've known people, not known them personally, my family has friends that were taking ivermectin that was prescribed by a doctor. By the way, taking animal grade ivermectin is a huge, like that could be bad because the dose is way off, way off. And
Right.
people are doing that and they're getting harmed. But
Yeah, that's a strange thing, isn't it? That they
did it
haven't
with
made that distinction?
hydroxychloroquine too. Like
Right.
people were doing
They were
that.
taking fish
People
cleaner.
Yeah,
fish tank
exactly.
cleaner.
They were
Yeah.
doing that. But again, I know people that were anti-vax and they were taking ivermectin and they ended up in the ICU. And what could have
They
prevented
ended
that?
up in the ICU
The
from
husband.
ivermectin?
No,
Or no,
with
from,
COVID.
Okay.
They got COVID and then it was like bad.
and they
this
were
was
taking
the father.
animal grade?
No, they were taking ivermectin. They had gotten ivermectin.
Were they taking the
I don't know. I mean, so there's the dose, and
Right.
but here's also it is a safe drug,
Right.
And but most of the times that it's used with our whole safety history is 1 to 2 days. So that's what it's prescribed for
right
all those things.
for river blindness and things along
and
those lines?
scabies,
right?
and so it's like what effect is having it once a week have for multiple weeks? I don't know.
Right.
I don't know, honestly.
Right.
But
we don't know.
we
Right.
don't.
Yeah.
I personally think people should get vaccinated. I think it's safe. I think people should make that decision. I mean, based on information. I hope they choose to. I'm not telling someone to do something, but I hope they choose to. It is the safest way to protect yourself from this and also to help us get our society back to normal and also help not overwhelm ICUs because you don't want to get in a car accident or have a heart attack if the ICU is full. It's bad, right?
We're at 3 hours. Unfortunately, I got a tight day today.
Yeah.
I got to
Well,
bail out of here.
there you have it.
Is there anything else? Do you have any final thoughts on this?
I've got a lot of thoughts on it, but I think we talked about some good. We didn't talk about the fertility, but there's many studies that have come out showing it doesn't affect fertility. And
what do you
so
think
far.
about pregnant women getting it?
Well, there've been studies, large studies that have now been done with pregnant women getting it, and I think it's bad to get SARS-CoV-2 if you're pregnant. So I think a woman has to make the decision whether or not they're going to be exposed to it if they're working a job and have to be out.
Do you think there's any additional concerns about getting vaccinated while you're pregnant?
I think the data so far has suggested it seems to be okay, particularly when you compare it to getting SARS-CoV-2 while pregnant. And that's pretty much the bottom line. I am always, with pregnancy, in me, it's always kind of like the most conservative you could ever do,
Right.
And so like that's my nature. And I again, I have that luxury because I don't have to go out and talk
Right.
to people. I can stay home and work and not interact with anyone.
Right.
If I were like a grocery store worker, someone that's like in the service industry or someone that's going to be exposed, like I wouldn't want to get the SARS-CoV-2. I wouldn't. Like, and there's been studies that it is harmful, like during pregnancy. So, yeah.
That's a wrap. Rhonda, you're awesome. Thank you very much. Let everybody know where they can get a hold of your podcast, find you on social media, all that good stuff.
Yeah. My podcast is on Spotify. It's on Apple Podcasts. Found My Fitness, all one word, is the name. I'm also on social media with all that stuff. And my website, I have a JRE page. It's called foundmyfitness.com/JRE. It has timelines and notes to every podcast we did with references to a lot of the stuff talked about for all other 9 of them, and soon to be this one as well.
That's an insane amount of work to do all that.
Yeah. But it's nice to have references. People want to dive deeper.
It's amazing to have references. So thank you very much for doing that, because that's really cool of you. And look at all those times we've talked. Wow, way back to 4:59. That's crazy.
That is crazy.
Always a pleasure. Thank you so much for being here. I always appreciate your perspective and your information and all your research and everything. So thank you,
Joe.
Thank you very much. Bye, everybody.